Good morning, sir. Good morning, participants.
Good morning, madam.
Good morning, sir. Good morning,
Madam,
all.
Madam,
It's a
shall I
great
start?
pleasure for me to introduce our resource person, Dr. Sanjay Kumar Panda Garu. Dr. Sanjay Kumar Panda is working in the Department of CSC at NIT Warangal, Telangana. He worked as the head of the department CSC at IIITDM Kurnool, Andhra Pradesh. He received PhD degree from IIT Dhanbad, Jharkhand, MTech degree from NIT Roorkela, Odisha. He has vast years of teaching and research experience. He received 20 plus awards from IEEE, ISTE, CSI, and others, which includes 2 silver medal awards for the best graduate and best postgraduate in CSC. IEEE senior member and ACM distinguished speaker, and he has published 100 plus papers in reputed journals and conferences. He is a member of IEEE, IE, life member of ISTE, and life member of CSI. His current research interests include cloud computing, artificial intelligence, machine learning, and Internet of Things. He delivered 90 plus invited talks and chaired sessions in many national and international conferences. He acted as a reviewer in many reputed journals of IEEE, ACM, Elsewhere, Springer, and Handel, and many reputed conferences also. He also served as a guest editor in many international journals. Sir, Dr. Sanjay Kumar Panda, sir, I am requesting you to take over the session.
Thank you very much, Anjali madam, for my introduction. So let me share my screen first, and please confirm whether my screen is visible or not.
Yes, sir, visit.
Okay, thank you very much. So good morning to all the participants. Before we start today's session, I would like to thank the coordinator of this program, Professor K. Amarendra, head of the Department of Computer Science and Information Technology, Professor B. Harikiran, head of the department CSE, Professor P. Sai Kiran, professor and head of the Department of Artificial Intelligence and Data Science, and the faculty members, staffs, for giving me an opportunity to take a lecture in this program, that is practicing cloud computing with Amazon Web Services. So in this session, in this 1.5 hour session, 90-minute session, we are going to see some of the research problems related to the cloud computing. So you already have spent one day in the AWS infrastructure. Today also you are going to learn more about the AWS infrastructure, but you have to see what are the research issues with respect to the cloud computing, and how you can solve a research issue using any cloud computing platform. One of the example is your Amazon Web Service, or you can say Google Cloud, and somebody interested in other cloud service provider as well. So this is the agenda for today's presentation. So first we'll discuss about the emerging trend in the cloud computing, which is now called as the public cloud computing, and its future is for the statistics given by the world's leading research and development firm, that is Gartner. So now you can see, if you see, the plain cloud computing term is not that much popular, because already around 13-14 years from its birth, many people are now aware of the cloud computing. So you have to identify which area of cloud computing you should work, so that you can contribute something to the cloud computing. Basically, due to time limitation, I am going to tell you only 3 research problems related to the cloud computing and their state of art. First, we are going to see the problem of resource allocation and task scheduling. If you are searching research paper in this domain, then you will see a couple of, you can say around 50, more than 50% papers are based upon the task scheduling or resource allocation. But these two terms are different from each other, that we are going to discuss while we are discussing this particular topic. Not only this resource allocation, nowadays energy also plays a very much important role. Whether you are working in the field of cloud computing, or you are working in the field of wireless sensor network or vehicular radar network, any field you are working, irrespective of the domain, now energy is a very much issue, right? The energy cost is drastically increased. So we have to see that how we are going to minimize the energy while applying our model. So with respect to that, we will discuss some of the algorithms with respect to the energy efficient cloud computing. But you know that we are relying on non-renewable energy, like petrol we have, gas we have, that we call as a fossil fuel. So you know that non-renewable energy sources is going to be, we are going to face the scarcity by 2040 or 2050. So if you are going to depend how on these non-renewable energy sources, then in future we are going to face problem. That's why many cloud service providers like Amazon, or you can say Google and Microsoft, they are running their data center using renewable energy sources. So in addition to this non-renewable energy like fossil fuel, we have also used renewable energy like solar or wind or hydropower, biomass. These things we are also using to supply energy or power to our data centers. So with respect to that, we are going to discuss the third research topic, followed by the conclusion and list of references. Now coming to the Gartner Hype Cycle, I told you that Gartner is a world's leading research and development firm. So Gartner provides statistics about various emerging technology. Earlier, people are focused on emerging technology. Nowadays, we are focusing on a specialized technology. Let it be cloud computing, or let it be our Internet of Things or artificial intelligence and machine learning. So, with respect to each and every popular research domain, Gartner is going to provide some statistics. The statistics provided by Gartner not only accepted by academia but also accepted by industry. That's why you will not get the latest hype cycle of Gartner in Google, right? For example, you are seeing here the Gartner hype cycle, which was released in July 2019. So every 6 months, Gartner is doing some kind of survey. They are conducting interviews. They are looking into the market and generating this particular hype cycle. So in this slide, you are going to see some of the aspect which is released in July 2019. But the latest cycle, if you ask in 2020 and 2021, it is not available. But you can see in July 2020, Gartner released another hype cycle related to the cloud security, because you know security is a primary issue in the case of cloud computing. So they released various areas that aligned with our cloud security. So if you see this particular hype cycle for information technology in Gulf Cooperation Council, that is GCC, so it was predicted that the public cloud computing will grow for the next 2 to 5 years, but its adoption will take more than 10 years. So you can see also here, this hype cycle is generated with time versus expectation. With respect to the time, what is the expectation of a particular technology, right? You can see in the x-axis we have time, y-axis we have expectations. So every technology is coming to the market as a new technology. So it will be present in the innovation trigger, the first part. Gradually, people are habituated with that technology. So it is going to a peak phase. So once the technology is mature, it is again leaving the peak phase. So here also you can see we have used several colored dots by Gartner. Gartner represents this technology by several colored dots. Like you can see, if something is mentioned with white colored dot, like you can see here, private cloud computing is mentioned in a white colored dot. It indicates that this technology is always more or less it is a mature technology, and its plateau is going to be reached within 2 years. But if you see this colored dot, it indicates the technology will sustain for 2 to 5 years. This colored dot represents the technology will sustain for 5 to 10 years. Triangle indicates the technology will sustain for more than 10 years. And if any technology marked cross, it indicates the technology is obsolete. So you have to pick a particular technology which is there in the market for at least 2 to 5 years. Like you can see, there are several technology it is mentioned. If you see this public cloud computing in Gulf Cooperation Council, so it is mentioned that its adoption is going to take more than 10 years. So if we can contribute something to this particular domain, then definitely it is going to be accepted by the community. Similarly, you can see nowadays artificial intelligence and machine learning plays a very important role. One of such technology is called as a digital twin. So digital twin is merging the living entity with the non-living entity, or you can say virtual world with actual world, physical entity with logical entity, right? So such technologies are there in the peak phase of the Gartner hype cycle. For example, if you see in the digital twin, it is expected that it is going to be present in the market, and its demand will be there in the market for 5 to 10 years. So this is going to give a motivation to choose a particular area of the cloud computing to work. That's why I have shown you here the Gartner hype cycle, so that you can pick a particular topic, or you can suggest a particular topic to your PhD scholars, MTech student or BTech student to work in that particular domain. Now, if you see some of the statements by some of the researcher of the Gartner, first I would like to tell you about the statistics given by the Vice President Analyst of Gartner, G. Patry. So he told that by 2023, the leading cloud service provider like Amazon and Google will have a distributed ATM-like presence to serve a subset of their services. I'll tell you this example based upon the current scenario. During this COVID situation, all the hospital in the first phase, all the hospital do not have the facility to test whether a particular person is positive or negative. So what they are doing, they are simply collecting the samples, and these samples are sent to some head office kind of thing, or district headquarter, or to the state quarter, right? State office in the capital of a particular state to check whether a particular person is having positive or negative. For example, I want to communicate each and every patient through their email or their mobile messages to provide a report that whether the person is positive or negative. So if you see, if you are dealing with a very large number of populations, you require more computation power, which a single computer system will not provide. So if you are subscribing a cloud service provider, your actual infrastructure may be anywhere in the world, but it is not possible to extract your infrastructure near to you, right? That's why he suggested that just like our ATM, our city is having so much ATMs. So whenever we require money, we are going to the ATM to collect the amount, right? So the ATM is very close to the customer rather than the bank, right? So these cloud services are also going to be provided like an ATM. Suppose in the X location you require more computation or more storage, immediately the cloud service provider is going to provide the service over there. And if you see, these data centers are generally the data centers are they are do not have any mobility. Suppose a data center is placed in the Mumbai, and later point of time it is required to set up a data center in Pune, then you cannot move the data center from Mumbai to Pune. But now you can see, just like we have a big truck kind of thing in which there is a container, the containers are having massive amount of computation power as well as storage, so that at any point of time if there is any resource requirement, the truck can reach to that particular location and the container can provide that services. It is just like a distributed ATM. So there are four trends predicted in this particular decade. First one is the cost optimization will drive the cloud adoption. Why the small scale industry to the medium scale industry peoples are heading towards cloud? The reason is that they don't have sufficient amount to run the business. They don't have sufficient budget to run to purchase their infrastructure and run its own. That's why the small scale industry and medium scale industry, which is having the scarcity of the budget, they are moving to the cloud. And cloud can provide the resources as per your requirement. For example, today you require 100 server, tomorrow you require 10,000 server, the day after tomorrow you require only one server. Such type of flexibility can be provided by cloud, and this can be also obtained with less cost. That's why the cost optimization is attracting the various industries or various organizations to move their infrastructure to the cloud. The second trend is that multi-cloud will reduce the vendor lock-in. So if your institute is attached, for example, nowadays we are more or less adopted an online meeting platform like WebEx. Each and every organization is adopted something like maybe Google Meet or maybe Microsoft Team or maybe by Zoom to conduct the class. But if you see the functionality of each and every online platform, there is some common functionalities are there, but there are some extra features are there in one software which is not there in other software. Similarly, if you move from one cloud to another cloud, you will say there is a difference in their features in terms of various services. So whenever suppose you have subscribed to a particular cloud service provider X in some day, and you are happy with cloud service provider X, but later point of time in market we have a cloud service provider Y, and that cloud service provider is going to provide you with the best feature in comparison to cloud service provider X with the lowest cost. Then you may plan to move your service from cloud service provider X to cloud service provider Y. But the APIs, the programs, whatever there in the cloud service provider X, that is not there in cloud service provider Y. So you are going to face one problem which is called as the vendor lock-in problem. So you are locked with a particular cloud service provider. You cannot move to another cloud service provider. But you know that the resources of a particular cloud service provider is not infinite. We call that as a unlimited resources because the term unlimited refers to a value where we cannot reach. So when there is a scarcity of the resources among the cloud service providers, they are going to collaborate each other to provide various services, which we call as the multi-cloud infrastructure. So when various cloud service providers are going to integrate together to provide a unified service, this vendor lock-in problem is going to be reduced. The third one, the trend is that suppose in an organization has decided to move to the cloud. So they want to deploy everything into the cloud. Basically, they are moving from the traditional infrastructure to the cloud infrastructure. But the people who are involved in this migration process of that particular company or organization, they don't have the background that how to move this thing to the cloud, which I can say here that is called as insufficient cloud infrastructure as a service skill. So as they don't have any expertise in this particular field, it is going to delay the migration process from that particular company's infrastructure to the cloud infrastructure. It also triggers us and motivates us to gain the infrastructure as a skills so that this migration process is going to be smoother. So by 2023, you can see in the market also this type of jobs are going to be created. The last one is the distributed cloud will support expanded service availability. When multiple cloud service providers are going to be attached together to provide the services, so we can see at any point of time if any service is required and if there is a scarcity of the resources, another cloud service provider can provide that services on behalf of that particular cloud service provider. So these are the four trends that is going to impact this particular decade of in the field of the cloud computing. Similarly, if you see here, in 2020, the annual revenue, if you see in US billions of US dollar, it is 270, $270 billions of US dollar in 2020 is the revenue of the public cloud service provider. But however, due to these COVID situations, we are more relying on cloud. We are more relying on this online platforms, which is running on cloud. So the annual revenue is expected to grow 23.1% in 2021, which is not expected in 2020. 2020, they are expecting that maybe there is an improvement of 17% or 18%, but due to this COVID situation, it is drastically increased. And infrastructure as service secured the highest growth in 2020 due to the data center consolidation. And as said by the research vice president of the Gartner, Mr. Sid Nag, he mentioned the cloud adoption is in mainstream and it will take 2 to 5 years to complete. Here also you can see the statistics we are providing from the forecast period 2018 to 2022 with respect to business process service, with respect to application infrastructure service, with respect to application services, with respect to the management security services and system infrastructure services. So if you see this the forecast period from 18 to 22, the software as a service, the software as a service is dominate all other services of the cloud. Like these online platforms are also a software as a service of the cloud, which we are using to interact with each other. Similarly, you can see not only in the 2018, also up to 2022, it is predicted that more revenue we are going to get in the case of software as a service. And Amazon is also very much popular in the case of providing this infrastructure as a service. I told you that Amazon provided two very popular services. One is Elastic Compute Cloud, we call that as EC2. Another service it is providing S3, that is simple storage service. The first service is for the computation and second service is for the storage. So these two are the very popular service coming under our infrastructure as a service, which is provided by Amazon, and it is also leading in infrastructure as a service. So one cloud service provider may provide better services with respect to a services, like Amazon is best for infrastructure as a service. Some cloud service provider may best for platform as a service. Some may be best for the platform as a service. Like Professor Rajkumar Bhuya also developed one software that is called as Anek, that is produced by Manjara Soft Australia. So that is a platform as a service which is widely accepted by academia as well as various government organizations. Like China government also have adopted this particular software in order to uh, apply in specific applications. So let us discuss the research topics in the rest of the time. So with this introduction, I will tell you about the 5 research topics. The first research topic I want to discuss here, that is called as resource allocation and task scheduling. So if you see the research articles, these two terms are used alternatively, just like a synonym, right? But the difference between the resource allocation and task scheduling is there. For example, if you want to go for a particular application, you want to host in the cloud, for which you require 30 virtual CPUs. I'm writing vCPUs. So I need 30 vCPUs to run that particular applications. So you are going to get these virtual CPUs from the cloud. So you have requested a particular cloud service provider. You know these services are provided on demand and self-service. Nobody is going to approach to the cloud. You have the only person, or through a broker you are going to subscribe for this particular service. So when you are requested for 30 virtual CPUs, a cloud service provider is going to provide these 30 virtual CPUs from the pool of resources, and there is some pricing model you have to adopt to pay the fee for this 30 CPUs. For example, you are going to pay, let's say $0.02 per hour for virtual CPUs. If you go for Amazon EC2, you can see the pricing scheme with respect to the type of vCPUs you have subscribed. Like Amazon Web Services is having T2 micro instances, they are having large instances, they are having X large instances. So these instances, if you see, the capability of the virtual CPUs are increased from the micro instance to the X large instance. Suppose you have subscribed 30 virtual CPUs to run your applications. So Amazon is going to provide the 30 B CPUs with some cost agreement to you, right? And you are basically going to sign a service level agreement between the cloud service provider and the customer. Okay, just like whenever you are purchasing a particular product from the market, there is a warranty card and a guarantee card. So that is a agreement between the consumer and the provider. So once the SLA you have signed, SLA is going to provide the details about that particular service, just like our terms and conditions, so that in future, if any complication will be there, then that can be resolved by looking into this particular document. So assigning 30 CPUs to a particular client by a cloud service provider, or if you are requesting 30 CPUs to run a particular application, is called as your resource allocation. The resources are allocated you to run a particular applications. But once the resource is allocated to you, your job is to decide which module or which particular task you are going to assign to which virtual CPU. Like 30 computer systems are there. Each and every computer systems, you are going to execute a chunks of your applications. So if you can order that one, which one you are going to assign to machine one, which you are going to assign to machine two, and so on, that particular order is called as the problem of task scheduling. So these types of problems generally happens in the infrastructure as a service cloud. But any kind of scheduling, if it is required for the platform as a service, like many cloud service, many customers are requesting for a particular platform. Someone is using requesting for a software as a service. You can apply scheduling strategy based upon the services requested by the user. So the cloud services here we have, there are 3 services. One is infrastructure as a service, platform as a service, next one is your software as a service. like we are using Facebook, Twitter, Google Documents. These all are coming under our the software as a service. And platform is just like we are using a Windows platform, we are using a Linux platform, Android platform. Such platforms are also can be provided by your cloud service provider. But you have to ensure that the infrastructure for set up that particular cloud is available to you. Otherwise, you have to go for multiple cloud service provider services from a particular cloud service provider. Now, if you see in the client's perspective, not only a single client is going to communicate with the cloud service provider, there are multiple clients are requesting the resources to the cloud service provider. So in what way you are going to assign these requests to the resources? One side you have customer, another side you have provider. So you require an intermediate unit. Sometimes we call that as a broker. The broker is going to decide which client application is going to be executed in which resource. So based upon that, you are having three different modes. For example, upon receiving a client applications, you are immediately allocating to the resources. That is called as your immediate mode of execution. But if you want to retain the customer applications and within a particular time frame, let it be 1 hour or 2 hour, whatsoever the request you have received, that you are assigning to the resources, then that is called as the batch mode of the resources. So if you dispatch it immediately, that is called as your immediate mode. But if you dispatch it by in a batch, by collecting some of the request with respect to a time period, then we call that as a batch mode of the execution. Then similarly, you can go for a mixture of this immediate mode and batch mode. So you can say with respect to that, if 5 tasks are arrived at a particular period of time, you can assign these tasks to the resources. But while we are talking about a particular application, generally these applications are represented in the form of a directed acyclic graph. So in directed acyclic graph, suppose if I draw a very simple graph like this, A, then followed by B and C, and followed by B. Once B is completed, you can start D, and once B and C is completed, you can start E. So if you consider this directed acyclic graph where each and every one like A, B, C, D, E are called as your task, then you can see in a particular model, the task may be dependent in nature or the task may be independent in nature. Like here you can see once the task A is going to be complete, you cannot start B and C prior to that. Or once B and C is going to be complete, you cannot start the task number E. So it is purely depends upon what is the structure of the particular applications. So based upon that, you can decide how you are going to assign these tasks to the resources. So it may happen that all the tasks are independent in nature. They are not dependent on each other. So in that context, you can run multiple tasks at the same time. But in the dependent case, you have to see how many tasks you can run in parallel. So that is going to be one type of problems. So basically these are the bins we have, and you have to choose one element from a bin in order to develop a resource allocation and task scheduling problem. Similarly, you can see there is a static element of the resources and we have dynamic allotment of the resources. In dynamic cases, you can see based upon the customer requirement, you can expand the resources and you can provide it. Static case, you have a predetermined situations. Based upon that, you are going to assign it. Similarly, upon arriving a high priority task, you can preempt the low priority task as well. So that is called as your primitive scheduling, what we have studied in other subjects as well. So in the primitive scheduling case, if a high priority task is coming, or we call that as a VIP task, so such task is given as more priority in comparison to the normal task. So you can print a particular task and you can give priority to some other task. So the policy may be primitive policy or it may be non-primitive policy. Similarly, the environment you are considered, like for example, if I take 30 CPUs, or if you see a particular computer lab of an institute, if the lab is having 30 computer systems, more or less the configuration of these 30 computer systems are same. They are having same architecture. Their hard disk size, their RAM size, their processor, everything monitor size in inch. If you see, these all are having the same type of structure. So such type of environment is called as homogeneous environment. That means if a task is assigned to the first machine, how much time it is going to take, it is same as if the task is assigned to other machines, because it is a homogeneous environment. But the second environment you can see here, which is a heterogeneous environment, in which one machine's configuration is different from another machine's infrastructure. So in that case, you cannot predict how much time it is going to take in the first machine, or how much time you are going to take in the second machine. Or you cannot say that it is taking 5 seconds in the first machine. That means it is going to take the same 5 seconds in another machine, because both machines are having different infrastructures. Similarly, whenever we are dispatching some task, we are maintaining the quality of service. So this quality of service is also divided into two parts. One is called as high quality of service, another is called as low quality of service. If a customer is not providing any input to a particular parameter, then that is kept in the low quality of service. But when a customer has specified a particular requirement, you are bound to fulfill it. Otherwise, you are violating the service level agreement. In that context, we call that as a high quality of service. Similarly, if you form a particular matrix, okay, and this particular matrix is in between, let's say, your different set of tasks, and on the other hand, you have different set of cloud, okay, and if you would like to find that how much time it is going to take for a particular task in different cloud service provider, and if you can form a matrix to represent this execution times, then it may happen that multiple tasks are taking same amount of time, or multiple tasks are taking less amount of time in one cloud service provider. Or it may happen that based upon different tasks, they are taking different time in different cloud service provider. So what I mean that for all set of the tasks, maybe C1 is the best cloud service provider in comparison to other cloud. Or even if you are saying in a particular cloud service provider, if you have multiple virtual machines, then one virtual machine is outperforming in comparison to other virtual machines. If such a thing will happen, we call that as a consistent matrix. But it is not possible that for all every type of task, one machine is outperforming other machines. So such matrix is called as your inconsistent matrix. There is another variation of the matrix which is called as your semi-consistent matrix. Semi-consistent matrix says that the part of the matrix, inconsistent matrix, is called as a consistent matrix. For example, you have 5 cloud service provider and 5 different tasks. So you can form a matrix of size 5 cross 5. But out of this 5 cross 5 matrix, let's say 3 cross 3 matrix, one of the 3 cross 3 matrix is consistent. So we can call that matrix as a semi-consistent matrix. Now you can adopt various strategies in order to implement the scheduling algorithms. For example, if I will tell here in this context for this particular directed acyclic graph, if I say you, we have two different processors. So this is nothing but the multi-processor scheduling. For example, you have two virtual machines. This is your first virtual machine. This is your second virtual machines. So you will start execution of task A in one virtual machine. And once A is completed, you can simultaneously start B and C. So you can choose out of B and C, one you can assign in virtual machine 1, and you can start C in another virtual machine. But as the result of A is going to be sent to both B and C, so it will take a little bit time to transfer some temporary results, which is there in the case of after completion of the task A, we need to send to the virtual machine 2 in order to start the task C. But B case, it is not required because you are running in the same machines. And once B is completed, you can start D immediately because D is only dependent on B. And once C is completed, and you have to check that whether B is also completed or not, then you can start E. Then here also you require some amount of time to transfer the data of B to the task number E. Okay, so here if you see this particular context, what I can say you that whenever you are executing the task A in the virtual machine 1, if you see look into the virtual machine 2, virtual machine 2 is completely idle. Okay, so what you can do here, you can apply the approach of a task with duplications. So what you will do, you will also run the task A into virtual machine 2. So you will get two advantages if you run the task A into virtual machine 2. The first advantage, you have made the task duplication. In case the task A is failed in the virtual machine 1, you are going to get the result from the virtual machine 2. Second advantages is that you require some time to transfer the temporary results after the task A is completed. You have to send that result to the virtual machine 2 in order to start the task number C. So in this case, if A is executing, a replica of A is executing in virtual machine 2, this particular time we can avoid by the help of this task with a duplication approach. But duplication will definitely provide you a better solutions, but unnecessary duplication is also delaying the execution of the applications. Similarly, we have different type of leases in order to deal with the resource allocation problem. The first type of lease is called as advanced reservation lease. So one of the popular open resource manager, that is called as Agia, supports these leases. So advanced reservation is just like booking a train ticket before you are commencing the journey. So a particular berth in a particular coach in a particular train is allotted to you. You have to travel from your source to the destination. So in advanced reservation case, you have to mention that at what time you require the resources and up to what time you require the resources. For example, I can say I require the resource at 11 a.m. and I need to continue up to 1 p.m. and I need two number of virtual CPUs to complete my work. So such type of lease is called as our advanced reservation lease. There is another type of lease that is called as best effort lease. Just like we are taking a counter ticket and traveling in any train from the source to the destination. So in the best effort, what happened? You will say that we require two virtual CPUs and we require a 2 hours of executions. But at what point of time you require these 2 hours of execution, you are not going to mention it. By assuming that whenever the resource is free, the resource is going to be assigned by the cloud service provider. So in that context, we call that lease as the best effort lease, in which we are not mentioning any specific time. So if you compare these two, advanced reservation and best effort, then you will see obviously the advanced reservation is having more priority in comparison to best effort. So best effort leases are less costly in comparison to advanced reservation. That is the reason once an advanced reservation lease is arrived, while you are executing a best effort lease, you are going to preempt the best effort lease and you have to give priority to your advanced reservation lease. Similarly, there is another lease that is called as immediate lease. Immediate leases are need to reach to the cloud service provider and it need to start immediately without any delay. So most of the immediate leases are rejected by the cloud service provider because when you are requesting the immediate service, it may happen that the service is not available. If service is available, it is immediately going to be provided. Otherwise, the request is going to be uh, rejected. And a more stricter form of this best effort lease, which we call as the deadline sensitive lease. So you are mentioning you require two virtual CPUs for 2 hours, but you are saying these 2 hours should be before night 12 a.m. Okay, you have given a particular deadline. It may be 11 a.m. to 1 p.m. It may be 12 noon to 2 p.m. It may be evening 5 to evening 7. It may be late evening, let's say 9:30 to 11:30. Anything is allowed, but you have to give me a 2-hour resources before night 12 a.m. So based upon that, different types of leases are there. So there is a open resource manager is there. You can download this IGA who supports these leases to execute the task, which is also used in the by various cloud service providers. So you know, whenever you are developing a particular algorithm, you have to again check the performance of this particular algorithm. For example, you will see how many leases are reached to the cloud service provider, and how much leases are accepted by the cloud service provider, and how many leases are rejected by that particular cloud service provider. Based upon that, you can see the efficiency of the scheduler. Similarly, you can see how much resource is utilized by the cloud service provider. And if a group of tasks is assigned to the cloud service provider in the form of an application, what is the best time to complete the entire application is called as the make span of that particular task. So if you are interested to work in this particular area, you can use the very popular simulator that is called as cloud sim, or you can use the MPI platform, message passing interface platform, which is similar to C program. In addition to that, we have some specific commands are there in MPIs to implement these algorithms. So here I want to tell another type of problem. So here you can see, you can go for a centralized model or you can go for a distributed model. Like I told you, future of the cloud computing is nothing but multi-cloud, in which all the cloud service provider are going to collaborate each other to provide the services, and the service is going to be a unified service. For example, if I say this is your cloud service provider 1, this is your cloud service provider 2, this is your cloud service provider 3, and this is your cloud service provider 4. Let these cloud service providers are collaborated each other. They have a common portal kind of thing in which the customer can request the resources, and there is a broker present in the centralized node which is going to decide which cloud service provider is best suitable for this particular requirement. For example, some cloud service provider is providing IaaS, some cloud service is providing platform as a service, some cloud service provider is providing software as a service. So they are integrated each other. So the main role of this particular broker to classify the based upon the requirement of the customer, which cloud service provider is best suitable for that particular requirement. And you can see each and every cloud service provider is having the manager server. The main role of this manager server is to keep track of the resources of the data center, or keep track of the resources that is available inside the cloud service provider. So they know that whether the resources are free or not, whether their utilization is more than 70% or less than 70%, and when they are going to free, okay, and how much remaining resources are there, whether a particular application can run with the remaining resources or not. So whenever a broker is going to assign a particular task to the cloud service provider, or a client's requirement to the cloud service provider, it has to consult with the manager server. The manager server is the person is going to tell, okay, that is the unit is going to be decide that whether the task can be completed in the cloud service provider or not. Now you can see here, suppose a particular application reached to the manager server. Okay, this is a centralized approach. You can also go for a distributed approach. You know, a centralized approach may fail. If this particular centralized unit is failed, then the entire system is collapsed. That's why many people suggested to go for the distributed approach. In the distributed approach, you can do that a particular user is going to request to a cloud service provider. If that cloud service provider has not enough resources to complete that particular work, then that cloud service provider is going to migrate that particular requirement to some other cloud service provider. But it has to ask the resources to other cloud service provider to provide the resources. So actually this particular user will know that the service is going to provided by cloud service provider one, but actually it is provided by other cloud service provider. So if you go for such approach, the manager server of a particular cloud service provider is going to receive the applications, and it is having the responsibility to divide the application into number of tasks. So that is nothing but the partitioning of the task, partitioning of a particular application, which is also a very challenging problem. So once you decompose a particular application into number of tasks, then you can decide which task is going to be executed in your own cloud and which task you have to send to some other cloud. If you are going to send to some other cloud, they are going to going to be transferred to the waiting queue of that particular cloud. And if it is assigned to your own cloud, it is present in the waiting queue of that respective cloud. And once the execution of the task is completed, again the result is going to back to that particular cloud service provider, and the manager server is going to consolidate these things and return the result to the customer. So in that way also the application is going to be partitioned, assigned, and they can be scheduled and executed in various cloud service provider. So here I am telling you a PO research problem so that the idea will be more clear. Here I have considered there are three different applications. So here you can see I told you each and every application is in the form of a directed acyclic graph. So here you can see I have taken three different applications, and each and every application arrived at a different period of time. Like you can see, first application arrived at time 0, second application arrived at time 3, next is arrived at time 9. Okay, and each and applications are having a particular mode. For example, the first application is in the BE mode, second application in the AR mode, third application in the BE mode. So you can see that once you are executing a particular BE task into cloud service, okay, if a AR task is reaching there, then that can print the BE task and it can execute the AR task. Again, the BE task is going to be resumed once the AR task is going to be complete. Like for example, now B task is running in some cloud service provider, okay, and F task is reaching there. So B task you have to print and you have to start F task because it is advanced reservation task. And once F is completed, you are going to resume the B task again. So here we are generating a expected time to compute matrix, which we called as a ETC matrix, expected time to compute matrix. Like for example, if I take, there are three different clouds are there, or three different virtual machines are there inside a particular cloud. So I am estimating that if I am going to execute a particular task in a particular cloud service provider, how much time it is going to take. So this can be also predicted by taking how much instruction you are going to execute in the cloud or how much data you are going to process in the cloud. Based upon that, this particular time can be extracted. So this matrix is generated. You can see if you look into this matrix may be a consistent matrix, this matrix may be a semi-consistent matrix, or it may be an inconsistent matrix. For example, you can see for the task 1, the best one, task A case, the best cloud service provider is nothing but your cloud 1. But if I ask for task B, you will say the less time is taken by cloud 3, so cloud 3 is best. But for task C, the cloud 2 is the best among the three different clouds. So there are several types of algorithms are already applied in this particular field. I'll tell you the very simple algorithm, that is, you know about the round robin scheduling algorithm. So round robin scheduling algorithm is not taking care of this particular matrix in order to assign a task to the cloud. So round robin is following a particular sequence or order in order to assign the task to the cloud. For example, in this case, round robin is assigning the first task to the first cloud, B task to the second cloud, C to the third cloud, and D to the first cloud, E to the second cloud. And once an application is over, again it is starting from 1, 2, 3, 1, 1, 2, 3. So these are the different clouds it is provided. The sequence you can find from this particular row. But as you are not looking into this expected time to complete matrix, your result is not going to be better. You are unnecessarily utilizing the resources without thinking about your goal. So round robin is not a significant algorithm if you follow a particular order without focusing on this etc matrix. As a solution, another algorithm is there that is called as a list scheduling. So list scheduling says that you have to look into different solution, different execution time of the on different cloud service provider, and you have to choose a cloud service provider which is taking the least execution time. For example, the first task is assigned to the cloud one because it is taking less time on that. Then for the task B, it is assigned to the third cloud because it is taking less time on that. And for task C, it is taking 2 unit of, in the second cloud, it is taking 3 unit of time, which is least among 3 different clouds. So we are going to assign that. For example, if you see L case again, the first cloud service provider is taking less amount of time. So we are going to assign to that particular cloud. So in this way, if you do, then you are going to perform a better result in comparison to the round robin scheduling algorithms. So there are not only this particular parameter, there are a lot of parameters are also applied to this application scheduling, or we call that is a workflow scheduling. So the first parameter is nothing but a T level, or that is called as soon as possible. So if a directed acyclic graph is there, right, and you can also take this particular parameter in order to decide which task is going to be assigned to which cloud. For example, here you can see, if you consider this particular parameter T level, or we call that is a as soon as possible. So it is saying you have to find the length of each and every individual task. But while you are considering each and every task, you have to take the starting task to the current task. For example, if I consider this task A, and this is the task B, and this is task C and D and E. So in the T level case, what happened? So you have to, if you are want to find the what is the T level value of the task A, so you have to check on the its distance from the start task to the task A. But in this case, the start task is also A and the current task is also A. So the T level is, can be say that you can say that the T level is 0. But if I say what is the T level of task D, then you can say the distance from A to D. So while you are calculating the distance, there are two things you have to consider. One is called as the computation time. Each and every node is taking the computation time. And in between two different tasks, you have communication time. Both you need to concern in order to decide this particular parameters. Similarly, B level is another parameter in which we are doing the reverse thing. So for example, if I'll tell you, find the B level of a task B, then you have to calculate the distance from B to D, where D is the end task. Also, you can see in this case, E is also one of the end tasks. So you have to determine the length of B to D as well as length of B to E, and whichever you are getting maximum, that you are going to be taken as the B level of task B. So once you determine the T level or B level, or you can go for static bottom level by taking the task Ti to the end task. But in this case, we are only considering the computation time without considering the communication time. Or you can also apply the critical path method. Critical path is the longest path between the start task to the end task. So based upon the critical path, there is another performance measure that is called as late as possible. So once you determine the critical path, you can subtract the end task to the current task path from the critical path in order to find the value of as late as possible. So these are the various parameters you have to determine for each and every individual task. Once you determine this one, in the T level case, it is mentioned that the task with the lowest T level value, for example, task A is having lowest level value, that is 0. So that need to be assigned first. Now BC is ready. So there is a value for B level. There is a value for a task B, that is the T level. T level for C is also available. So you have to check these two values, that is T level values of task B and C, whichever is least, that you are going to assign as the next task in the into the processor. Okay, so you may see that these particular applications are also you can generate, or you can use some real life applications as well. For example, if you mention how many tasks are there in the directed acyclic graph, what is the depth of that particular graph, what is the width of that particular graph, then through a random directed acyclic graph generator, you can generate such type of applications. So that is generating a particular type of data sets which we call as a synthetic data sets. But you know that many times the synthetic data sets are not accepted because it is not following a particular structure. That's why there are many real life applications are there, data sets are available, which you can use to uh, implement these resource allocation and task scheduling algorithms. Some of the real life workflows are, Montage is one of the workflow which is belongs to the astronomy project. Similarly, CyberSec is another workflow which is belongs to the earthquake science project. Epigenomics is another workflow which is belongs to the biology project. LIGO is another workflow, real life workflow from gravitational physics, and SIPST is another workflow from the biology domains. So these workflows, the standard structure is already there, and you have to generate the computation time of each and every task and the communication time of the between two different tasks. So based upon that, you can execute your scheduling algorithm, and these are the benchmark data sets which is available in this particular field. So as an example, just I am showing you here three different workflows. One is Montage, another is called epigenomics, another is called as SIPST. So if you look into these three applications, then you will see that structure of these applications is different. Like here you can see there are 4 number of entry tasks are there in the first figure. There is only one root node in the second figure, and there are more number of nodes, root nodes are in there in the C figure. So based upon the structure also you can take advantages of the scheduling, right? For example, in this case, you can say, I have assigned this task to the processor number 1, and I have assigned this task to processor number 1, processor number 2, processor number 3 and 4, and it is going to execute in the same processor. These 3 tasks are going to assign in the processor number 1. These 3 are going to assign to processor number 2 and so on. And once it is done, again processor 1 is consolidating everything and executing the rest of the task. So total number of processors or cores or the virtual machines required to complete this epigenomics is only 4. Okay, so it purely depends what is the width of the graph. Based upon that, you can predict how many processing elements or functional units you require to execute your applications. So these are the real workflows that you can use in order to implement your algorithms. So if you are interested in this domain, so I have given the entire literature survey from 1999. Prior to the cloud also, there is so many algorithms are there, which is later used in the cloud computing as well. So I've given the references also. So you can go through these references and try to know about this particular research topic, and you can develop new algorithms in this particular domain. And there are some standard data sets are also there. If you want to implement small scheduling algorithm by based upon the log files of different data center or log files of different machines, there are some standard data sets are also there. One of the data set size is I want to discuss here, that is called as 512 into 16. So here 512 indicates the number of tasks and 16 indicates number of machines. Number of machines. So you have to assign these 512 tasks into 16 different machines in a heterogeneous environment. Heterogeneous means the time taken by the task T1 in one machine is different from another machines. So you have to develop algorithms to implement that thing into various machines. So these data sets, whether it is 512 into 16 or 1024 into 24 or 2048 into 36, and this is 36, and or it may be 4096 into 48. So these all type, these data sets are following a particular structure that is called as U underscore X underscore YY underscore ZZ. So here U is nothing but the uniform distribution that is used to generate these data sets. X is nothing but the type of matrix which we discussed, that is whether it is a consistent matrix or a inconsistent matrix or it is a semi-consistent matrix. And YYZZ indicates the machine and task heterogeneity of that particular scheduling problem. Sometimes the machine capacity is very high in comparison to the task capacity. Sometimes the task capacity is more in comparison to machine capacity. Or another case, you can say both are maybe high, both are maybe low. That's why the YYZZ value may be high and low. Based upon that, each and every data set is having 12 different instances. So out of these 12 instances, if your result is better in more than 6 instances, then you can claim that your approach is better than the existing one. So this is all about the first research topic. Let us I'm heading towards the second research topic. As I mentioned that energy is also a very important factor whenever you are doing some kind of scheduling algorithms or irrespective of various field. Now energy plays a very important role. So earlier people are focusing on how we are going to maximize the utilization of the resources. But now in addition to this, people are focusing on how to reduce the power consumption. So earlier also people have assumed that there is a linear model between the CPU utilization and energy consumption. But practically, if you see the modeling between, or if you draw a particular graph between CPU utilization and energy consumption, you will see this graph is not a linear one. And there is also some of the facts just I want to tell you that if you see the data center, the power consumption by the data center, if you compare with the number of householder, it is earlier mentioned by Professor Buya, it is 25,000 householder, but now it is more than 50,000 householder. The amount of power consumed by 50,000 householder is same as the energy consumption by a single data center. And imagine how many data centers we have in all over the world. That's why it is very much important to take care of this energy. And you have to see that so if the resources are not required, you have to put the resources in the idle or in the sleep mode. Instead of idle mode, you can put in a sleep mode or switch off mode in order to save the energy. And if you see the ICT resources case, some report also stated that ICT resources are taking 8% of the total energy consumption, and it is going to reach 50% by the next decade. And the power or the electricity, if you see, is generated by various organizations from various sources. Like in India, we are also dependent on some renewable sources like water. So dams are there through which we are generating the power. But if you see in the US context, the US electricity case, you can see 66% of the US electricity is generated using the coal and natural gases. But whether these renewable non-renewable resources will there after 2050 or not, that is a questionable. And there are various statistics also says that 91 billion kilowatt of hours of electricity is consumed by the US data centers, and which is reached 140 billion kilowatt by the end of 2020. That's why energy plays a very important role in order to you can say that how we are going to save the units by minimizing the number of resources. So this is the graph just we have, you can say it is traced by taking different IP addresses. In x-axis, we have considered the utilization from 0 to 100%. In y-axis, we have seen, we have represented the power consumption. Just we want to know that if the utilization of the processors, okay, or utilizations of the resources is increased, then how it impacts on the power consumptions. So here you can see the earlier this model is assumed to be the linear one, as I told, and now it is we are considering this model is a not linear one. So here you can see in this particular graph, especially after 70%, the way the graph is increasing, and if you see in comparison to before 70%, it is a huge gap. So that's why I told you this is the relationship is not a linear one. So if I ask you, suppose you have a particular virtual machine in which you want to execute two different tasks, right? One task require 30% of the resources, another task require 50% of the resources. So you know the sum of these two task requirement is 80%, and maximum you can provide 100%. So both can be assigned to the same virtual machines. Okay, so the utilization of that particular virtual machine is 80%. But on the other hand, another person can suggest a solution. Why not build two virtual machine? One is virtual machine 1, another is virtual machine 2. Virtual machine 1 is busy for 30% of time, and virtual machine 2 is busy for 50% of the time. Right? That is also one of the solutions. So if it is a linear one, the relationship between the CPU utilization and energy consumption is a linear one, then there is no issue. But if it is not a linear one, then what is going to happen? You can see that after 70%, the amount of power drawn is grown exponentially. So that is going to impact the cost of the energy. So that's why you have to see whether the solution 1 is going to be the better one or solution 2 is going to be better one based upon these type of traces done in a particular data center. So here you can see we have divided the utilization into various level. Like we assume that the level 1 is called as the ideal level, where the utilization is 0 to 20%, and 20% to 50%, more or less the same increase is there. That's why we are representing by level 2. And level 3 is 50% to 70%. And in each and every 10% after 70%, we are going to take one level. So once you have given this particular level and you have given a particular threshold value, like many researchers suggested that don't go beyond this 70%. It is better to switch on another machine when the utilization rate is exceeding 100%. Sorry, exceeding the 70%. So this is the problem which is we are going to see in the research topic 2. So you are having multiple virtual clusters. So in each and every virtual cluster, you have physical machines. And on top of the physical machine, you can deploy several virtual machines. And these virtual clusters are also going to be integrated each other. Okay, these virtual clusters are also going to interact with each other to transport their task, because we do not know at what point of time the resources are overutilized or the resources is underutilized. For example, whenever virtual cluster A is fully utilized and requests are also reaching to the virtual cluster A, the request can be transferred to either virtual cluster B or C or to any other virtual cluster, subjected to the availability of the resources in that particular virtual cluster. That's why there is a bandwidth matrix available in between the virtual clusters. So you can say there is a, if you want to transfer a particular task from virtual cluster A to virtual cluster B or C, this is the bandwidth you have to consider. That is 250 MB you can transfer per second, or 500 MB per second if you are transferring the task from virtual cluster A to virtual cluster C. So based upon this system model, let us see how actually the processing is done. So here we have given different kind of a task. So I have taken only 5 different tasks submitted by different uh, customers, right? And we have represented the task in the form of a tuple, right? Where we are considering the arrival time, processing time, and utilization. So in this case, you can see task 0 is arrived at 0 unit of time, and it is going to take 20 unit of time, and it is going to utilize only 40% of the resources. So what I did here, I have created a particular resource R0 in which I have assigned a task T0 from 0 to 20, and it is utilizing 40% of the resources. The next one, T1 is arrived to the system. T1 is taking, starting from the 3 unit of time. It is taking 8 processing time. So it is starting from 3 plus 8. So it is going to complete by 11 unit of time, but it requires 50% of the resources. But if you sum these two utilization, they are not exceeding 100%. So I can assign these two into the same machine. So you can see the task 1 is also assigned to resource 0, which is taking 50% of the time. But when the task 2 reach to the system, it is starting, its arrival time is 7 and it is going to take 23 unit of time. That means it is going to complete by 7 plus 23, that is 30 unit of time, but it requires 20% of the resources. But there is a overlap with the task number 0 and task number 1. And if you sum these three utilization, they are exceeding 100%. So you cannot assign the task 2 to the resource 0. That's why we have created resource 1 and assigned the T2 into resource 1. Similarly, when the task 3 arrived to the system, it is arrived at 14 and it required 10 unit of time. So it is going to take from 14 to 24. It requires 40% of the utilization. So here the challenge is coming. The challenge is that now you can assign the task 3 to the resource 0 and also you can assign T3 to resource 1. So you have to develop a particular mechanism which is going to decide whether T3 is going to be executed in resource 0 or T3 is going to be assigned into the resource 1. So there is an algorithm that is called as maximum utilization. Maximum utilization is saying if you are once you are assigning T3 to a particular resources, if the utilization is maximum, then you go for it. For example, in this case, if I ask you for a particular period of time, what is the utilization? You will say 40% by T1, T0, and 40% by T3. So sum of these utilization is 80%. Okay, but if I ask you here, then the utilization is only 60%. So obviously the utilization is more in R0, so I am going to select choice 1 as for the maximum utilization. But there is another algorithm which also says that the sub choice 2 is better than the choice 1. So you have to claim by taking a particular power model or energy model in which you will claim that whether choice 1 is better or choice 2 is better. There is another algorithm just I want to discuss with respect to research topic 2. Many researchers also suggested that if you are going beyond 70%, the power consumption is more. Okay, that's why they put a limit that we should not exceed the limit of 70% of each and every virtual machines. So it is better to switch on another virtual machine when the sum of the utilization is exceeding 70%. But the main interesting thing is that suppose cluster A is now can create at max 3 virtual machines. Okay, and now 3 virtual machines are occupied with 70% utilization. Like here you can see task number 6 is coming after assigning the task 0, task 1, task 2, task 3, task 4 and task 5, and task 6 need to be assigned to somewhere in the cluster A. But cluster A do not have any sufficient resources to execute it. For that reason, what happens? Cluster A has to communicate with cluster B that I need to execute task T6 in your cluster, whether the resource is available or not. Or it has to contact with cluster C in order to say that whether we can execute the task 6 in your cluster or not. Again, it also depends upon what is the bandwidth limitation between two different clusters. So if their resources are available and the utilization rate is not exceeding 70%, then you can assign into the respective virtual cluster. But it may happen that the virtual cluster B and virtual cluster C is already preoccupied with their own task. Okay, they are already uh, occupied with the preoccupied task. So when task cluster A is approaching cluster B and cluster C, unfortunately the resource is not provided. In that case, what happens? You have to exceed the limit of 70% in your own cluster in order to accommodate the resources to the customer, because customer requirement you have to fulfill as per the service level agreement. Then after that only you have to think about different parameters like energy, whether it is a renewable energy or non-renewable energy. But when the customer requirement is not at all satisfied, then you have to exceed these limitations. Like 70% we have exceeded here. Here you can see utilization is 80%. Although the more energy is consumed with respect to these task number 6, but we don't have any other option because cluster B and cluster C is already preoccupied. So if you are interested in this particular topic, so you can go through these algorithms, that is random algorithm, ECTC algorithm, max util algorithm, etc, ETS algorithms are there. So you can also study these algorithm and propose new algorithm in this particular topic. So as the time we have reached the end of this particular lecture, quickly I will cover the research topic 3. So I told you, whenever we are concerning about energy in the last decade, we focus on how to minimize the energy. But in the current decade or the last part of the decade, people are focusing on the renewable energy. What is the main motivation of going for renewable energy? I told you in the second research topic, the amount of power required for 50,000 householder is same as the power consumed by a single data center. So if you see in all over world, we have 8.6 million of data center. This is as for the last survey. But if you see the day by day, the data centers are increasing. And you can see in US only, there is 3 million data centers are there. And in each and every data center, it also varies with respect to different data center, whether it is a mini data center or it is a large data center. But in average, we have 50 to 80,000 servers in each and every data center. And in order to run the data center, you require 25 to 30 megawatts of power. And also one survey stated that the global data center requires 416 terawatts of electricity per year. So see how much energy or power is required to run the data center. So these data centers, as I mentioned in the US case, they are using coal and gas. So maximum energy is generated based upon the non-renewable energy sources. So coal, gas, petroleum, these are also we are using to generate the electricity, and it is drastically impacting our environment by generating the carbon dioxide, by generating the particles, and heat is also generated by these non-renewable energy sources. So as a solutions, what you can do, we can move toward the renewable energy sources like biomass, hydropower, solar, and wind. And Google and Microsoft already claimed that their data centers are fully powered with renewable energy sources. But if you see the fact about these particular data center, although they are powered with renewable energy sources, but they are not detached from non-renewable energy sources. What is the reason? The main reason is that the renewable energy sources are not available round the clock. They are not available 24 into 7. Solar energy is not available into 24 into 7. So it may happen that the environment is cloudy. It may happen that in summer season water is not there. In some season wind is not there. So generating electricity through the non-renewable energy sources is always a question mark. So as a solution, what you can do, we have to use both renewable energy and non-renewable energy, and we have to run the data center with renewable energy first. And when there is a scarcity of the renewable energy, then we can use the non-renewable energy sources in order to run the data centers. Like here you can see the data centers are powered with grids as well as the non-renewable renewable energy sources like solar panel and wind. So whenever there is a sufficient resources is available with a renewable energy, then we will go for it. And when there is a scarcity, we will depend upon our grid. So with respect to that, Professor Rajkumar Bhuya also developed so many algorithms. One of the algorithms I'm going to discuss here. He modeled each and every user request in the form of three things. One is the start time, another is the node requirement, another is duration. And the cost of using these renewable energy sources is different from the cost of using the non-renewable energy machines. So here you can see this colored one, right? These colored ones are called as the non-renewable energy sources. So these machines are running under the non-renewable energy sources, and these white marked are running under the non-renewable energy sources. So these are renewable energy sources, and these are non-renewable energy sources. So, for example, if somebody is using renewable energy sources, the cost is less. If somebody is using non-renewable energy resources, then he has to pay different cost with respect to the time. So for example, you can see the task number 1, that is U1, is assigned to the data center 1. Okay. and it is executing for 4, the unit of time it is going to execute is 4 unit of time. So U1 is assigned to 4 unit of time and requires only one resources. Similarly, U2 is assigned to the data center 1. It requires only one node and for one duration of the time. U3 is assigned to, let's say, data center 2, and it is taking 4 unit of time, and it is taking only one node. Suppose this is a snapshot already taken. Now, suppose U4 is coming. We have decided in some manner that U1, U2 is going to be assigned to data center 1, and U3 is going to be assigned to data center 2. But whenever U4 is coming, you have to decide whether data center 1 is better for that or data center 2 is better based upon the availability of the renewable energy. So for that, there is an algorithm called as future ever best fit algorithm. So future ever best fit algorithm mentioned that you have to choose a data center where you will result the lowest cost for that particular user request. Like here you can see U4 require it is to start from 3 unit of time, and it is required 2 nodes and require 5 unit of time. So we have mapped U4 with data center 1, we have assigned like this, and we have also mapped U4 with data center 2 in order to calculate which one is best. Whichever is best, that I am going to take. So here you can see, this is this the top one. The first one is going to take 1 unit of non-renewable energy, for which you have to pay the cost of 0.3. Here also you are using the non-renewable energy, so you have to pay a cost of 0.2. The total cost in the data center your D1 is calculated as 0.5, and rest amount of the slots you are using renewable energy, for which you need not pay any cost, or you have to pay some standard cost. But if you go for the data center 2, here I am using one non-renewable energy slot. Here I am using 2 unit of non-renewable energy. So the cost is 0.3 plus 0.3 plus 0.3, it is 0.9. So out of which the minimum is in data center 1. That's why it is assigned to the data center 1. The U4 is assigned to the data center 1. Similarly, if you assign, you will get the complete scheduling or in both the data center. So if you are interested in this particular domain, these are the algorithms developed in the last 5 to 6 years. So go through these particular algorithms, and you can develop new algorithms which you can implement. And if your result is producing better, then you can go for the research articles. So as a conclusion, I can say we have seen the importance of public cloud computing in Gartner perspective, and we have seen the revenue generated in US $1 billion from 2020 to 2021, so that you will able to know that what is the importance of cloud computing in the market. So in this session, we have focused on 3 research topics. One is resource allocation and task scheduling. Second, we have focused on the energy efficient cloud computing. Third, we have seen what is the demerits of the non-renewable energy sources and why the renewable energy sources are one of the alternative for the non-renewable energy sources, and why we need both in order to power the data centers. And these are the some references, so you can go through it if you are interested in these 3 research topics. So thank you everyone. If you have any questions, you can ask. Somebody mentioned that my research topic covers the CPU utilization. Can you please forward your PPT? Okay, I'll share my PPT with Dr. Amrendra sir. So please, sir will forward to you, to all the participants. So you can make utilize of these resources. And any point of time, if you require, you can contact me for this type of problems. Any other question by any participant? You can unmute or you can write in the chat box if you have any question.
Participants, If you have any doubt, any query, you can ask with Dr. Sanjay Kumar sir. Okay. And he is a very, okay, one of the questions is
Yes,
has come.
one question is
Yes,
about the task offloading. Actually,
yes,
what
sir.
happened in between the if you see by the emerging of IoT in Internet of Things, you know that IoT devices are there in the close to the ground, you can say, but cloud is very far from the these devices. Devices are generating the data, but analyzing this data and processing the data is done in the cloud, where cloud is very far from the IoT devices. So in between this IoT and cloud, we have another layer, that is fog. So fog is a not a replacement to the cloud. Fog is a complementary to the cloud. So fog bring the
Super.
same type of resources, but not in that much capacity, which is close to the ground. That's why these devices, whatever data they are generating, which we call as the task,
Voice
it
is
need
too
to be
high.
offload to the fog devices in order to process it. But if you require more number of processing, again the task need to be upload to the cloud to process it. So that is the concept of task offloading. It is actually introduced in the fog computing domain. Is it clear?
Participants, anyone else?
Okay.
If not, thank you, Sanjay sir. From the KLU side, we all would like to express our sincere thanks to you for giving an excellent lecture for cloud computing. We also wish to express our gratitude to you for providing such kind of encouragement at cloud computing, because within a very short span of time, uh, you have covered all the literature survey related to the cloud computing. Really, it was a very amazing and a very wonderful session for all of us, sir.
Thank you very much, Pawan sir.
Yes, sir.
Thank you to all the participants for patiently listening me.
Okay.
Thank you, everyone.
So participants will again join from 11, okay? And from 11 a.m. onward, an hands-on training on AWS will be going on. So for 15 minutes, there is a tea break. It's a virtual tea break for, of course, for all of us. And Samuel sir will take over the sessions, hands-on session. So you all people be ready with the system, okay? Pawan sir, am I audible, sir? Pawan sir. Connected. Samuel, Stephen Samuel. Now we tell him in the WhatsApp, sir, please connect. Stephen sir, Stephen sir, Stephen sir.
Hello, yes, can you hear me?
Yes, sir. Yes, sir.
Oh, great.
Good morning, sir.
Good morning, good morning.
It's me, Naveen from KLU side, sir.
Okay.
So very healthy. Good morning to you, sir.
Okay, great. And I hope you have a good session today.
Yes, sir. Yes, sir. We all are expecting that that session would be very attractive as well as
Sure,
fantastic to
of
all of
course
us,
it will be.
because lots of feedbacks are coming from the participants that they are so much audible to start the hands-on session like that.
Yes, yeah, that's right. But the first day I warned them that we had to get into a lot of, the theoretical foundation. But the rest of
Yes,
the week
yes,
will be a lot of hands-on,
yes, sir,
very
yes, sir, yes,
practical,
sir.
very. But of course, we won't ignore the conceptual foundations, but there will be plenty of hands-on for everything.
Yes, sir.
Every single topic that we take in a particular day, every single topic will have a hands-on
Yes, sir,
or
yes, sir.
two, definitely.
Actually, we all know that to start the hands-on, we must have some conceptual background knowledge about the cloud. Only,
Mm.
only when we could complete our hands-on training very conceptually as well as successfully.
Yes, otherwise you won't know what you're doing, not with
Yes, yes,
AWS,
yes.
because it's very complex actually. There's
Yes, sir.
too many moving parts. So you have to
Yes,
have a clear understanding the whole like AWS infrastructure, and then you can actually work intelligently.
yes, sir. Yes, sir. But audience are
You'll work
audience are.
intelligently, you'll know what you're doing. Also, there's a
Yes,
lot
sir.
of configuration,
Yes, sir.
and we'll be going and doing we'll be looking at, we'll be connecting directly through the console also to AWS. So that is there. That is where developers do their programming. We'll do simple stuff, simple programs. All the programming does when you open a console window to connect to AWS and you set up install your programs on your instance. So there'll be plenty of hands-on, but the first
Yes,
day it's like this.
sir. We all people know
Anyway,
that
they
what
were patient
a
enough.
yes, yes, sir. Yes, sir. Yes, sir. We are counseling them to please have a patience. And just from the second session, you are going to start hands-on training, so you don't be hurry. Okay.
Yeah, that is right. I did
Yes, sir.
tell them though. I told them a few times also. That hands-on will only come in the second day onwards. And everything, actually, all the basic course outline, training outline that I received is a lot of hands-on that can only be done with hands-on.
Okay. Yes, sir. Yes,
Those
it is agreed, sir. Without
scenarios.
so participants, you would be ready. Participants, are you there? Please use the chat box. Okay, okay. So they all are, sir, eagerly
Ready.
waiting.
Okay,
Uh,
fine. Fine. So good morning, everyone. Welcome to day 2. Today we are going to do a deep dive into AWS, specifically EC2, the compute aspect of AWS. And one of its core services, you would likely use EC2, create an EC2 instance for any application that you develop. And as well as that, or something like S3, or both, probably both. So for today, we've done an overview. It was very necessary to get a thorough understanding of the infrastructure that we are working with, because as I mentioned, there's a lot of moving parts with AWS. So to work intelligently with the AWS Management Console, we will also be working with the CLI, the command line interface, to connect to AWS. That's why our developers use to actually write their programs and install software, for instance, on the instances that they have created. Okay, so if at any point I am not audible, just send me a chat, message on the chat, fine, and or just just tell me. That's best also. So a little bit of what are we going to do in this today? So now compute services, we took a little gander at it yesterday. So they're at the core of your application. So the cloud has evolved beyond simple virtual servers. It's not like the cloud hasn't been around for that long, but still tremendous advancements in a very short period of time, probably like less than a decade and a half. Now, so it's essential that we are familiar with the options so that we can design using the best practices available. So in this course, we are going to cover the different compute services. Today is devoted only to the compute services, specifically as regards, of course, EC2. But not only that, we'll also be looking at snapshots of EC2 related topics, serverless AWS, how to deploy a serverless application, and the Lambda, which are basically functions and they have their own pricing. So all that, but essentially this is a deep dive into the compute services offered by AWS. So there are a number of key options and configurations available for us for these services. So we need to understand that to maximize our performance and to minimize our cost. There are many options, myriad variety. We need to understand what is suited for us. And as far as performance also goes. Of course, we are on the free tier, so our options are limited. But still, it's sufficient to work with. So some of the major topics that we'll include will cover EC2, of course. Then AMIs. AMIs are Amazon Machine Images. And EBS, snapshots, lambdas, and serverless on AWS. So by the end of today, hopefully you'll be able to leverage the best compute option for different tasks. And you can be able to understand how to optimize your application performance because performance is key for web applications. It's a business requirement. Uh, Take advantage of services also to reduce our overall compute costs and our operational burden. Now, the number of AWS services can actually seem overwhelming. So we have to learn how to evaluate our compute scenario and choose the best service for the job. So first, we'll explore like core EC2 instances and how we can more securely interact with other services. Then we'll discover different serverless options. There's not only one serverless option in AWS, there's a number. And how do we actually use this within our application architecture? Okay, so hopefully by the end of this, we'll have the skills and knowledge of AWS compute services to choose the best services for any use case, any user requirement that we come across. Now, some of this we've done yesterday, but that was just introduction. Let's look at it in a little bit more depth before we move on to an actual demos. So by now, I hope everybody has got the Amazon Web Service account set up. And remember, and don't worry about having to furnish credit card or debit card details. It's Amazon, it should be safe. They'll charge 2 rupees as far as I know, and that's only for verification. And that too is returned after a few days, 3 to 5 days, something like that. But don't forget to put in that budget alert as we demoed yesterday. Don't forget that. That's very important. It's too easy to forget that you're on a free tier and then provision something, and that's out of your free tier, or you may exceed your storage, etc., the allocated storage, and then you'll find these charges appearing in your account. So we don't want those surprises. So make sure that that alert, budget alert, has been put on, and you'll immediately get it if it, and you have a threshold like 50 or 80%, you'll get an alert if there's anything untoward happening. Okay, so what now there's one more thing. You can open a command prompt. We will be using today, we will also be connecting to, there's a number of ways. AWS is for developers. Well, dealing with Amazon Web Services, not Amazon Prime, that's for shoppers. Anyway, we have a number of ways to connect. And I find the best is to actually connect from my own machine. You can actually connect from your console itself to an instance. So if you create an instance like how we just did a walkthrough yesterday, if you create an instance, then you should be able to connect with it and do stuff with it. That's your instance, and you're paying for it. So if you go to your command, open your command window, you should see something like this. Just put in SSH. Now, if you're on Linux or Macs, you have to check appropriately, but you should get something. So then SSH will be available. Okay, because we will connect to AWS. We actually not, we will connect to our instance via the console. Anyway, if so, check that. You might need to have an SSH client installed, or if you're on Windows, a Windows client. So just check that. You can check that now. You should get something like regarding usage. Then you know that you can use SSH on your system, because this is what we will need later. Of course, we can connect through the console, the management console. That is possible. If you can't set it up, then just to follow along with the course, you can do that. Connect through the console. The same thing. You can still operate the same way. So let us get into a little bit more about the fundamentals of EC2. Okay, so there's a variety. Let's start off by looking at that. There's a variety of resources available with EC2 instance types. So we look at that. Then we'll review the different storage options and the features available for use with our EC2 instance. And finally, we'll see the different components that affect the overall price you pay for an EC2 instance. It depends on your package in a sense. So you need to know the pricing. If you ever have a client requirement or you need to consult with the client, you'll need to advise them on the pricing for whatever options they are interested in. Now, EC2 instances, as we well know, they're one of the core components of AWS. Now, they represent this key value proposition of cloud computing, which is access to a variety of compute resources on demand. So whether you need just a few instances for development and testing, or tens of thousands for a large production system, EC2 is available to use when you need it without having to spend millions of dollars or lakhs and crores of rupees in capital months before you even launch a product. And that's what we saw with all our scenarios that we went through yesterday. Now, the kind of EC2 instances, there are several different types. I just want to ask, I hope this is being recorded. I saw it being recorded just now. It's very necessary that the recordings are available to everyone. Madam Anjali, is this being recorded?
Yes, sir.
Okay, great. Because it's, I think yesterday was skipped out. It's really necessary because it'll be very difficult otherwise. We can't expect everyone to remember because a lot of it is hands-on,
Yes, sir. Yes, sir.
and even the slides, if they do not remember a particular feature, they can go back to the recordings and refresh their memory. So it's being recorded and it'll be available to everyone. That's fine.
Yes, sir.
Okay, great. So now there are several different instance types, as we are saying. They provide a variety of CPU, memory, storage, and networking capacity. Now, each instance type includes one or more instance sizes, as we saw yesterday. There's large, there's extra large, for instance. So that helps us to optimize our workload for both cost and performance. Okay, let's review the 5 instance types that AWS offers. This is the last I know. You see, they are constantly innovating and adding additional instance types and sizes to take advantage of like new technologies and adapt to customers' needs. AWS is very aggressive in this respect. So there may be more at the moment. But anyway, this is what has been in place for some time. Of course, the first is the general purpose, and this actually gives you a balance between CPU, the RAM, and the network. Actually, that's what it actually does. So they're a good mix. Now you use these resources. General purpose you can use when you need this in like more or less equal proportions. You don't need one over the other. So the smallest and the lowest cost EC2 options are going to be in the general purpose category. Next, we got compute optimized. Now these machines are going to offer higher CPU performance relative to other resources and are good for compute bound applications. Now, what do I mean? I'm talking basically about high performance processes. We're talking about like scientific modeling, statistical analysis, data science related stuff, ad serving, video encoding, all that. Then memory optimized instances are designed to deliver fast uh, performance for workloads. Now, these actually process large data sets in memory. That is very difficult to set up on your own. So these can work well with like high performance databases, distributed in-memory caches, or real-time big data analytics. This would be perfect for that. Then we got accelerated computing instances. These use hardware accelerators to perform functions more efficiently than actually is possible than software running on CPUs. So they also well suited for machine deep learning, advanced analytics, graphic stuff, you know. And finally, we got storage optimized instances. These are designed for workloads that require high sequential read and write access. In other words, high input output. So that breaks it down to high sequential read and write access. So to very large data sets. on the local storage. So we're talking stuff like NoSQL databases, which is very popular, especially because it's like a document databases, but they are large. In-memory databases also, data warehousing, distributed file system, log processing, you can name it. So how would we select storage for our EC2 instance? Now, yesterday when we were setting up an instance, actually, we didn't even set it up. We just went through it really quickly just to get an idea. You came across this term over there, EBS, EBS, EBS. That's Elastic Block Store, as I mentioned. There's also, there's actually two other types. There's Elastic File System, or the EFS, and the Instance Store. So as we saw ourselves when we were creating that instance, which we will do again, when we need it in any case to create a machine image. So Elastic Block Store, or EBS, you'll have to just get used to these acronyms. Okay, because everything S3, will be storage, and EBS will be Elastic Block Store, EFS Elastic File System, and on it goes. You'll get used to it after some time. All right, it'll be second nature. So anyway, okay. So we were on to now with there are only some instance types. We'll come back to this actually. Instance, what is an instance? Okay, we'll talk about that. But there are only some instance types that operate on EBS only. Only a very few. We'll see. Now with EBS, we can create an SSD based volume, or we can create an HDD based volume. So SSD based volumes are also divided into two categories. The first is like general purpose. And as you can imagine, they're a good mix of price and performance for many types of transactional data. Now, these are the default EBS volume type for EC2 instances. So when we created, not like we had that many options being on the free tier, we will actually have this, the default EBS volume type. Now, based on volume size, you will be allocated a certain number of what they say IOPs. They are burstable beyond the limit for short periods of time, but may be throttled down to your allocated limit. All right. Now, the second type is provisioned. These are best for latency sensitive transaction workloads where you cannot throttle IOPs because it'll be problematic for your app. So to get the highest performance, this volume must be attached to an EBS optimized instance type. Now, HTTP based volumes are also divided into two categories. First, there's throughput optimized, and then there is actually that is good for frequently uh, access through throughput, intensive workloads, large data sets, large IO sizes like that. Second is cold HDD. This is the lowest cost volume, and it's actually more like you think of it as archives. You need to, companies will rarely get rid of that data. Data is the biggest asset a company has, probably. The second may be the actual human capital, and the rest would be, the machines and the plants and the equipment and stuff. Now, this cold HDD is the lowest cost volume is designed for less frequently accessed workloads with large cold data sets. Think archival. Okay, here we got a simple example to compare the cost of each EBS volume type. So your cost is calculated based on how much storage provisioned during the month. So just a very simple example. Pricing is an important factor. That's why it's there in everything that we discuss a little bit. If you're using provision IOPS, you'll also be paying an additional charge based on how many IOPs you provisioned. So here's the cost to use a 2000 gigabyte volume for 12 hours in a sample region. So our provision IOPS is like, it's actually, you break it down, it's something like this. Say $4.17 plus $1.08 for 1000 IOPs provisioned. So that makes it a total of 5.25, which is our green bar. So general purpose will come in at about 3.33. Throughput optimized and SSD is actually pretty low at $1.50. Cold HDD is at 83 cents. So you see the range. So with such a wide difference in storage options, it's important that you understand the requirements of your application and choose the correct volume type for your needs. Now there's also, as we will also see, we can have multiple volumes of different volume types. We create our EC2 instance and we can attach multiple volumes of different volume types to that single EC2 instance. So this gives you flexibility even within a single instance to optimize your storage needs. So we got a lot of options, frankly. Now let us look at Elastic File System or EFS. This is a managed NFS file system. So it's highly available and scalable and automatically grows and shrinks as you add and remove files. Now, so it's automatically scaling realistically. This allows you to pay only for what you actually use. So it's important to understand the distinction here between EFS and EBS. Over here is pay for what you use, whereas with EBS, you must allocate all of the space you think you will need to a volume, and you pay for the size of the entire allocated volume, whether you fill it with data or not. So with EFS, multiple instances can access the file system at the same time, making it a good choice for applications that need access to shared files. Now, EFS has several different options to fit your workloads. So here's our basic options, frankly. First, we can use the standard storage class and the infrequent access storage class. Just by the name, you can understand what kind of options these are. So standard storage is designed for files that are actively being used, and you pay for the amount of file system storage that you use per month. Infrequent access is designed for files that are accessed less frequently. So the monthly cost is less than the standard storage, but you will pay an access fee. So this is the catch. You can't actually just provision an infrequent access and access it at random. No, you will pay the fee. That is fine. The monthly cost, in other words, which is less than standard storage. But every time you read and write to a file, you will pay a fee. Now you can also configure lifecycle management to automatically move files from standard storage to infrequent access storage if they have not been accessed for a period of time. Actually, you specify that. Like, everything in AWS is configurable. You have to understand how to configure it. So for example, if you have an application that heavily uses new files for 7 days, then the files are only accessed occasionally as someone searches for them. You can set your time period to 7 days. Any file that has not been accessed for 7 days would then automatically be moved from standard storage to infrequent access storage. So this is actually a great way to take advantage of the lower cost of infrequent access by using this lifecycle management privilege option that is there. So you can take advantage of this lower cost of infrequent access while ensuring you won't incur excessive access fees. And now we need to look at performance over here for EFS. So for throughput, we can choose from two different modes. One is called bursting, one is called provisioned. So generally, we'd only need to choose provisioned if you need more throughput than is allowed by bursting. For I/O, we can choose general purpose or max I/O. Max I/O is pretty heavy, actually. This is optimized actually for applications where like hundreds or thousands of EC2 instances are accessing the file system. There's a trade-off like for slightly higher latencies for the operation, but this is what max I/O is. We're talking hundreds or thousands of EC2 instances accessing the file system. Okay, now comparing price with the example we use for EBS. If we use a 2000 GB EFS standard storage volume for 12 hours, it will cost about $10, or about 3 times the price of general purpose EBS. So 2000 GB EFS infrequent access would be about 83 cents. So this is about the same as EBS cold HDD storage. Okay. So this actually, this figure in front of you, it just gives you a sort of comparison between EFS and EBS. Now you need to keep in mind that with EBS, you pay for the entire allocated volume. So if you're allocating a 2000 GB EBS volume, you may only be using like 75% of that, or 1500 GB. Won't make a difference to your cost. So it may be more accurate to compare against 1500 or standard EFS, which is still over twice the cost of EBS at $7.50. Still. So depending on how much empty space you keep in your EBS volumes, they could make a difference to your uh, cost comparison. Okay, then lastly, lifecycle management, where your files are not accessed for a certain period of time, are moved from standard EFS to infrequent access EFS, which is the same cost as EBS cold HDD. So depending on your usage patterns, realistically, over several months, this could significantly lower your overall EFS cost. Okay, now instance stores, let's we actually don't have access to this on our free tier. So we can actually hmm, so we can take a look at it in the management console, but we cannot actually deploy it. We can't launch an instance store. Okay, we'll come to it. But we actually, we don't need it anyway. We are basically going to work with EBS for the duration of the course, and whenever we need EC2. But this would be helpful to understand how to create it and how to launch it. Now, finally, we have some instance types use instance stores. So what is that actually? This actually provides temporary block level storage located on disks that are physically attached to the host computer. So instance stores can offer some performance improvements for like frequently changing data like buffers, cache, scratch data, other temporary content that is replicated across a fleet of instances. That's why it's a replication aspect over here. So data in an instance store is ephemeral. It goes away. It actually only persists during the lifetime of an instance. It's a physical equivalent of an object in programming. All right. So if the underlying disk drive fails, the instance stops or the instance terminates, the data in the instance store is lost. So make sure that you got a source outside of the instance store for persistent data. However, there is one thing, for instance, reboots, the data will be preserved. Okay, so let's look at the components that influence the overall cost to operate an EC2 instance. This is crux of the matter, the whole point of this whole section. It's not only a payment type. As you can see, there are a variety of factors. You have to take all of them into account when you're doing your own pricing or you're evaluating different pricing options. So we got payment type, we got instance type and size, storage, and network traffic. Now, what are the payment types? So there are 5 ways, and let's go through it. You should be familiar with the payment types. On demand, I think we all know what that is. It's a simple pay-as-you-go price for an instance. So if you use it for 3 hours, pay for 3 hours. Now, savings plans involve the commitment to a per hour spend for your overall compute usage for 1 to 3 years. But this is in exchange for a discounted rate. Now, there's actually an automated advisor which we can access in the AWS Cost Explorer, which has to be enabled. You have to enable it. Now, this automated advisor can help you calculate if a savings plan can save you money based on your compute usage. So savings plans actually offer a lot of flexibility and can provide a good value if you have some level of constant compute usage. Reserved instances. This involves committing to a 1 to 3 year usage of certain resources. And they make sense if you have some constant resource usage or if you need to guarantee EC2 capacity. Then we got spot instances. These offer some of the lowest rates in exchange for short-lived or uninterruptible instances, which are suitable for fault-tolerant and distributed workloads. And finally, we got dedicated hosts. This allocates the entire machine, single tenancy, to you. It's actually like you bought your own server and installed it on the premises. Dedicated hosting, our traditional way of deploying applications. So dedicated hosts allocate the entire machine to you. So they are the most expensive. And it only makes sense if you require single tenancy. Now you could need it for performance. That is fine. You could also need it for compliance reasons. That is also there. We can't forget about that aspect. Now, the other three factors that affect overall EC2 costs are pretty straightforward. There's instance type and size are a direct reflection of how many and what type of resources your instance is using. The more resources available to an instance, the more it's going to cost. For example, this M5.24 XL will be more than an M5 XL because it uses 24 times as much CPU and RAM. Next, storage. Whether you choose EBS, EFS, or Instance Store, those all have different pricing based on the features you elect to use. Now, just remember, keep in mind that you'll pay for EBS and EFS storage whether or not the instances are running. You have to physically delete the volume for the storage charges to stop. Now, network traffic is often overlooked category. So we have to keep all this in mind when we do our pricing. That's why we are going through this actually. So there are different rates for inbound data transfer to your EC2 instance, intra-region data transfer between availability zones in the same region, and outbound data transfer to other AWS regions or out to the internet. So knowing your traffic patterns and the amount of traffic that you're pushing, that can help you decide the best products to actually use to optimize your network traffic costs. So finally, we're at the end of this module. So what have we actually, a few points to take away from this module. EC2 offers a wide variety of compute resources to meet our needs. These are organized by instance types and sizes. We also have different storage options available to use with our EC2 instances, including EBS, EFS, and Instance Store. There are several different configuration settings for EBS and EFS that we can customize depending on our usage and requirements. And finally, we know the components that affect the overall price we pay for an ESC to EC2 instance. Includes payment type, instance type, storage options, and network traffic. So selecting the proper resources and options based on our application needs and requirements can help us optimize for both performance and cost. Okay, so next we're going to cover different ways to leverage AMIs. Well, an AMI is an Amazon machine image. So we are going to cover different ways in which we can leverage AMIs for our EC2 instances. And we'll also, how do we use EBS snapshots? So I hope you'll have had a chance to check out whether SSH is enabled on your systems, right? Otherwise it's a simple thing. To just get a client, download a client for whether it's Windows or Linux, whatever you're using. It's a simple enough thing, uh, but I think it's best to actually do it from our, from our console. Once we set it up, it's very simple to connect also. If you've done it correctly, it's simple enough to connect. It's like you're working on an application on your own IDE or actually command prompt. I think we should actually, firstly, we'll have to do this a little bit differently. This might take a little while to set up. Let's create our instance now, and then we'll go to the back to the slides because it might take some time for the instance to be created. So we can't hang around twiddling our thumbs waiting for it. While that's going on, we can do something else. We'll go through the slides, understand what it is that we're actually working on. So we'll do it like that. So just log into your AWS Management Console, please. As I suggested yesterday, it'd be nice if you all worked alongside me. You will have less to review. At the end of the day, you won't have to go and sit through the recordings. You'll only need the recordings to as a refresher. But if you work through it, you'll actually come away with quite a bit understanding of what we've covered. So uh, log into your AWS, and it'll pop up over here. EC2, like a management console will pop up. So anyway, if you click on services, I hope everyone's with me. I don't want to rush, so everyone has a chance to just set things up correctly. We have to go to services. Of course, this is your dashboard in any case, but we go to services and compute, and we go to EC2. All right. What we are actually going to do, we are actually going to launch a couple of instances, one that is EBS backed and then one that is instance store backed. But as I said, instance store, we don't have access. We can go, but we can go all the way up to actually launching it, but then it won't let us, but we can see. It's not very important, but since it's over there and it's a paid option, a paid plan actually. So we should be aware how to get it running. So just click on launch instance. So here's actually all this is actually a list of AMIs which are managed by Amazon. That's what we've seen. That much we've seen already. And this is what we Amazon Linux 2. Amazon's version of Linux is what we will be using very frequently. So we can see a variety of operating systems and configurations. Now, if you click on my AMIs over here, I might have one. Okay, yeah, that's right. I made this. If you click on it, you won't have any as yet. That's okay. We are going to create it right now. Now, once again, under AWS Marketplace, you'll find many AMIs created by third parties. This includes a variety of free and commercial software. Now we can browse by category and even subcategory, for instance. So this one, for instance, we pay about $2.07 an hour. So this is paid. In addition to our AWS usage fees, depending on which EC2 instance is used to run it. So it's not actually very cheap. is $150 an hour. That's not cheap. But anyway, they do give you a free trial. Now, AMIs can be a great way to try out commercial software on a hourly basis and see how it works for you in your environment. So you don't need any setup costs over here. You can just try it out. If it works for you, good. If you can continue, or you can even go ahead and set up your own outside of everything. But uh, if it doesn't work for you, then fine, you can just move on. You made a small investment only. Now we can also select community AMIs. Now community AMIs list any AMI that has been made public and is available for use. So for some AMIs, you can see the company that provided it, like this was obviously provided by Red Hat. So before using any of these though, you would need to go through the same steps that you have used to evaluate any public software to determine if it meets your security and other requirements. Free doesn't mean better or best. It usually comes with some hidden costs. So anyway, you can filter your AMIs like by operating system, for instance. You can filter by architecture. Or even the root device type. Okay. So let's go back to the Amazon managed AMIs under Quick Start. And we just choose this, just like yesterday, we choose this, the T2 micro. Okay. See the network performance, for instance, is low to moderate. Like I mentioned in the slides, the local instance storage. For this, we have no access to instance storage for this particular selection, only EBS. So the data in the instance store is available only only for the lifetime of the instance. You can see quite a few. Okay, so that is now we've got this. For networking, we can simply just accept the defaults. You just want one instance. You can go through the different types. VPC is actually a virtual private cloud. So this also will request a public IP address. This is actually important. So make sure that this is always selected. Otherwise, our instance will not, without it will auto assign it. So otherwise, we can't, nothing will be able to reach our instance. Okay. So anyway, that will be auto assigned. There's nothing much over there to be done. Yeah, so that would be that. You can accept the defaults. Now for storage, This is the storage that we get. This is the snapshot. We look at snapshots in further detail later. The size that, of course, 8 gigabyte, general purpose. This is the number of input-output operations per second that this volume can support. So provision IOPs are not like is out of scope for us. Now what happens, this delete on termination. Now very often when you actually, you don't actually delete your instance, you terminate it. You can stop it, you can start it, and you can terminate it. I'm talking EBS instances, not not all options apply to instance storage. But for EBS instances, we can uh, terminate it. Now, when we finish our work, okay, I'd like you all to keep this in mind. Clean up your area because we only have limited amount of, storage given to us by AWS in the free tier. So when you don't need something just for practice, you find you do it and then you can terminate. Don't leave instances just hanging around. You can terminate, recreate it whenever you want. Now, when you terminate it, it will still show up in your list of instances. That's okay. Don't worry about it. It'll be there for some time and then after some time, it'll be removed or when you log in the next time. Okay, and now about this delete on termination, that the associated volume, the volume that is attached to this instance, if you terminate, normally if you terminate it, then the volume also goes away. That's also deleted. If you want to retain the volume to attach it to another instance, you can do that. So you need to uncheck this box. If you ever have that kind of, you have that scenario where you need the volume again for future usage, you don't want to delete it, then you can retain it. But in that case, you need to uncheck this box over here. Tags, we won't need, we won't look at tags anymore. Not at the present moment. Now I'll configure security group. Don't not like yesterday. Yesterday we didn't even launch it. We were just going through the interface. Leave the default option. Don't do a select. Leave the default option. But here, watch me carefully. Add a rule over here. Now come down to HTTP and make sure that that is selected. Okay. Everyone got that? Otherwise, you see by default, it doesn't actually allow. Suppose I select an existing security group. The problem with that, keep it like this. The problem being that it doesn't actually allow inbound connections. So you'll have problems connecting to Amazon, to your AWS instance. You're going to have problems. So make sure that this port, especially this port must be 22. So this will be there in any case by default. Make sure it is there. Make sure that you're on the first option, which is actually selected for you by default. When we come down to actually creating a web server, we would need this. So this says that for the HTTP protocol, type HTTP TCP protocol, These are the addresses that I'm allowed. That means basically everything, realistically, the whole of the internet. Otherwise, you won't be able to deploy your, I mean, you'll be able to install your Amazon, like actually Apache web server. You'll be able to install it on your instance, but no one will be able to reach your web page. So that is necessary. So especially, so just click this first option. If it's not there by default selected, make sure HTTP is done, and then I think we're good to go. Okay. So the instance store in this particular case, you know already, is backed by EBS. Now the next time, the first time you do this, you click the review and launch. Okay. Here's our ports, our types, our protocols, our instance details are here. They haven't actually specified the availability zone for us as yet. The storage is just default. That's okay. This warning will come up. Ignore it. They're telling you also that additional ports in your security group, you already opened port 8880. That's fine. But port 22 must be open so that you can connect. Now, okay, is just a second. We can, let's take a look at our instance details just to make sure everything's all right. Yeah, that's that. Now we can launch it. Now for you, the first time when this comes, I've already created this. You click on the drop down and you say create a new key pair. All right. I'll explain why that's important. Create a new key pair. This is your actually your public key, and you give it your name. You'll get a couple of input fields. An input field. You create a name for it for this key pair. This is how AWS authenticates you, so that you can connect to your instance. So this, we all know about public and private keys. This key pair is basically that. It's a public key AWS stores. So in a private key, that is what you are going to, they'll give you a download. Once you get that, you download it and store it in a secure location. You need access to it. I suggest that whichever, like, create some directory where you will be running your shell commands from. Okay. C:\, AWS, or wherever you want it. And store the actual, store the download, store it over there. So that when you need to pass in the location of that file when you're connecting. So rather than putting in a long path, if you're already in the directory, you can just put in the file name. You don't have to specify the path. So anyway, so initially you make you create a new pair. So go ahead and do that. Create a new pair, and then you will get a couple of fields. Just fill them in, give a name. Actually, the one input field, you give a name to it, and that will be your pair, your key pair, the name, and you'll get a link button. Click it and download it. Put it where you will be actually wanting to run your shell commands. Create a directory for yourself for this. The thing is that we can reuse the same rather than create a new key pair. Is no, I mean, it's just for our personal use, right? So we can reuse the same An existing key pair, we can reuse it no matter how many instances we create, but we have to do it the first time. All right. So that's done. I already created this EBS demos, excuse me. Okay. And then we can go ahead and launch our instances. There we go. So our instances are now launching. If we go back to EC2, well, that was quick. Sometimes it takes a very long time. Maybe it's a time of the day also that you created that matters. Sometimes it does take long. No, mine is not yet set up. Mine is initializing. I had a filter in place. So you can see here, mine is initializing. It's the fourth one. I guess yours will also be initializing, right? So this might take some time. So why don't we go ahead and move on? We'll come back to this when it's done. Depends on the network traffic also, I guess. All right, so let us go move on and let us go do some of, go through the background. So we get an understanding of how we can actually leverage AMIs, which are Amazon Machine Images, and our EBS. We can take snapshots, which is a nice option. So let's take a look at that. So everybody is on target with that so far. So we're just creating an instance. This is one of our instances we are creating. Then we start working with different stuff. First, we need to create our instance. So it's pretty straightforward. Of course, make sure that security group thing is addressed properly, the ports and all that. Fine. And then your key store, that key pair is very important. Download, keep it in a safe place. I'm saying keep it in the same directory because I don't have to put in a long path to wherever it is. I can just put the file name in the connect string, and we're good to go. All right, so let's move on. Let us work through how do we leverage our AMIs and our EBS snapshots. Okay, so this is welcome to leveraging AMIs and EBS snapshots. And this is like after the fact because we already started to create our instance, but we have to work like this, you know. So let our instance be created while we go through our stuff. Okay, now over here, what we are going to do is we are going to see how we can use and create AMIs, Amazon Machine Images for our EC2 instances and explore EBS snapshots, including how they work and when you would want to use them. So I don't want to talk too much about that because we look at it a little closer shortly. But Maybe some of y'all have worked, a number of y'all have worked with Docker. It's fantastic. Docker is, like gaining a lot of traction with DevOps nowadays, for instance. And it's more or less the same principle that I can see. If you install something on a particular instance, the reasoning is like this. You install something like a bunch of software, or maybe something like a Spring Boot application, or not even Spring Boot, any kind of application, or say a Spring application which has a number of dependencies all wired together, and you finally got it working right. All your dependencies, your jars, and your everything, your whole environment, you got everything installed and ready to go, and you got it working right on a particular instance. So with Docker, actually, you can you basically the reasoning is that you can create an image of that perfectly working software. Now, for software, as we very well know, that in deployment, this has been the issue historically, that we can configure one server and then we go ahead and configure another server, and the second one, something won't work, or it is going to die at some point in time for whatever reason. So if it does crash, if there's thank you, Mr. Naveen, exactly, a container management tool. So on those lines, that's what we are actually doing, right? And we're going to see it also. So on those lines, like Docker, there's so many. It's not Docker's not the only one. So if you can replicate that instance, which is where you got your perfectly deployed software and your perfect environment, then anytime there's a server fails over, you can actually copy the image there, and it'll be up and running again in no time because it's an image. So on those lines, loosely speaking. So that's what an AMI image is. Realistically, it is going to create an image of your instance. Okay. And there's a variety of ways in which we can use it. So we'll take a look at just a few. So what it actually is, it provides the okay, so we are also going to explore EBS snapshots, including how they work and when you would want to use them. Now, an Amazon Machine Image or AMI will provide the information required to launch an instance. It's not perfectly the same. This is Amazon, but generally speaking. So this includes permissions about who can use the AMI to launch instances and the installed operating system, software, configurations, and data all ready to go once your instance starts up. Right. That's the thing. The installed operating system, the software configurations, the data, well, everything all installed and ready to go once your instance starts up. So this is a thing with AMIs. AMIs save you the hassle of setting everything up each time you launch an instance. Or you can use one AMI to launch multiple instances with the same configuration. So we are actually talking about what? DevOps is like all about automation in a sense. This is also about automation. So this allows easy automation and setup of our applications and our environments. Now, an AMI will have one or more EBS snapshots or, for instance, store backed AMIs. A root volume template with the volume template will have the operating system and all the applications on it. It will also have a block device mapping. That actually specifies which volumes to attach to the instance when it's launched. You can attach volumes to the instance also. It does come with a default volume. That is true. As you saw, root / dev something like that. You know the path. But it does come with one. You can attach multiple volumes to an instance. So AWS provides several different AMIs we can use to launch EC2 instances. So the AWS, we can see that. The AWS marketplace we already seen. It provides a wide variety of AMIs to choose from. And we can also make our own AMIs. So when we go to launch an EC2 instance, we can select any of these AMIs to use for our instance. There's one thing to note though. Some AMIs have an additional cost to use. That is in addition to what you pay for the underlying EC2 instance. Some, not all, some. You have to take everything on a case-by-case basis. So this will vary based on the operating system, the software installed, and configurations that have already been completed in your Amazon machine image. So let us come back here, and mine is still initializing. Can someone let me know how it's going with y'all? Anybody who's got this running? Or can tell me what the progress is on your system? So as you can see, this is going to take, it does take time. Mr. Itu, you're saying it does not even show initializing. What is there? Does it actually show up in your list? In the status check, what does it show? Just a dash, an underscore. Really? Hmm. Can you check your network connection? It might make a difference. Uh, that is there. It should show initializing. If it's set up properly, it should show initializing. It could be network. Bandwidth can be, we're dealing with Amazon Web Services and it's pretty heavy. So check that. I mean, I have a decent broadband. How else can you run a training without it, realistically? But still, it is in progressing stage. Okay, okay, okay. Very good. So see, it does take time. This is what I meant, you know? Yeah, it does take time. Not an awful lot of time. It'll be there. It does take some time. We just have to organize ourselves. So let it run. Okay. Okay, good. If it's progressing, just let it be. It'll be there. At some point it'll be there. We are also on the free tier in any case, so it's not like we are priority consumers. Now there's something. Let us go back. Oh, very good. 2x2 check passed successfully. That's great. That's really great. Let me get some more feedback from others. Then we can actually move on. Don't worry about me. I don't need to wait. I have some other instances. I'll simply use that. That's not a big deal. All right. So, Mr. Naveen, that's 2x2 check. That's great. Just a few other people let me know because I don't want to actually move on until, y'all have actually completed this. This is completed. Okay, now there is something else. There's something called instance storage. So what we have done, as you can see, we can select our instance and we already know that this is EBS. That much we know already. I'm sorry, doctor, right? How did you shouldn't be at billing? Oh, I'm sorry. You are actually creating your account, right? Fine. Okay, okay. So yeah, that is something that happens. Now, when you get to that account, are you on the screen where they're asking you for your card number, your CVV, expiration date, etc. Is that the screen where you are? Okay, now it's fine. Very good. Okay. Uh, See, once you get to your billing screen, for anybody who's a little bit stuck, I got stuck, but that was because once you get to the billing screen, you had to enter in your credit or debit card information, your card number, the CVV, your name. Your cardholder name should not be actually the one that's on your card, is one registered for your account. So I put the name on my card, which is my first and middle name. It didn't work. Then it couldn't verify my account. Even though once I clicked on verify account, it went to my bank and for an internet transaction, and I approved that 2 rupees. I approved it, but I got a message back from AWS saying it can't verify. So I redid it again, and this time I put my full name as registered in my bank account, and then it got accepted. So do that, and then it should work. Then it should work. I used my debit card. I didn't use a credit card. So just try it. You can try it a number of times. The maximum they'll take is about 2 rupees. And in any case, they won't charge you for nothing. So just try that. All right. So when you are setting budgets, can you see, watch my screen? You come to click on like, here's my name, Steven Samuels. So you click on yours and you, all right, then you've logged in, I assume. Right? Then you go to your billing dashboard. Fine. Very good. Very good. Your budgets is over here on the left hand side. Like for me, I have got simply, here's you put your budget name. All you have to do, put your budget name, put your budget, and that's about it. Then you create your budget, and you also have your, once you create it, you'll get a budget alert. You can set that alert. I set mine to 50 or 80% of my budget. So I'll get an alert when it reaches $1. So good. If that's set up, sometimes setting up and configuring anything is the worst thing. Really. All right. So let us okay. So this is launching. Let's go ahead and launch another instance. Now this instance will be instance store backed. Okay. Let us go back to our dashboard actually. You can simply click on launch instances again. Okay, so we are going to make something that is going to be called instance store backed, as we discussed in the slides in the last section. So to do that, we have to go to community AMIs. So click on community AMIs over here, and then you scroll down and see our root device type. Okay. You just select instance store. Remember what an instance store is. Data is not actually there permanently, it's there only during the life of your instance. But I like to show you all this option. And I just go ahead and select any one. Now see this over here. Can you see how all the EBS instance types over here are disabled, including our free tier? Now I'm restricted only to those instances that allow an instance store, AMI. You get me? I can't launch an instance store AMI using an EBS only instance type. It doesn't make sense. So impossible to launch an instance store AMI using an EBS only instance type. So I have to actually, I'm restricted to only those instances that allow instance store. So let's look, I think it's within the R3 range. R3, let's see. R4, R5. That's funny. Huh. Only this seems available. It used to be R3. Okay. Doesn't seem very popular, this. So this is, okay, this is already pre-selected for us. Fine. Okay, so let's go with the default networking. All right, and that's just this particular instance. Wow, it comes with 2048 GB. All right. See the delete on termination, not applicable. In any case, it vanishes. Once the instance actually terminates, the volume, everything, the data, everything goes. Okay. See notice how the volume type is instance store, and we got 3 volumes. Let's skip tags. Here's our security group. I won't even bother asking you to even change anything in a security group, and in a moment you'll see why. And this is the reason. Our configuration is not eligible for the free usage tier. Okay. So even we can go and check this and that, but I just want beyond it doesn't matter, because even if we had set it up, I'd ask you all to delete it, because I just want you all to understand how you to set up an instance store. We have to go to community MIs and set it up if you ever need that. But for most users, we actually have we need EBS for our purposes. All right, so just simply click cancel. And mine is finally done. You should select, doctor, you should select from cost budget. As a matter of fact, you should only have that available. Everything else. But anyway, in any case, it's cost budget because your budget is fixed. So simply select cost budget. And that's all. So how's it going for the everybody else? Can we move on? Someone let me know. Okay, great. Thank you. So now we got our instance up and running. Yes. And this was 12, this must be mine, 1205. Let's select that. Go to our network, go to our security. Here's our outbound rules. Awesome. So everything should be set up to some extent. Now regarding that instance store, just one last thing before we lay it to rest. We can actually only reboot or terminate if in case we had actually created it. We could only reboot or terminate it, no other option. As soon as the instance stops, it actually goes away. So you can reboot the instance and have the data persist on the instance stored disk. However, take a look at this. For my instance and yours as well, if we select an EBS backed instance, notice how we can also stop the instance, as the EBS volume will not lose data when we stop the instance. We can also choose to terminate the instance, which I'm not going to do now, and not terminate the EBS volume. So delete on termination, remember during our setup, if we uncheck it. So then that volume would still be available and it could be reused with another instance or copied somewhere wherever we need it. Okay, so that's the difference between instant store and EBS. So let's log into our EBS backed instance right now. So simply, so you've selected your instance, select it like how I've selected it. So this is my latest instance. You can come here and click connect. And you see there's a variety of different ways that Amazon provides for you to actually connect to your instance. All right. Now this I have downloaded and it's actually in my downloads folder, which is in my C:/user Steve downloads folder. So by an SSH client is what we use. So as you see, read the instructions carefully. We got our private key file. This is where we downloaded it. Put it in the same directory. You don't need number 3. You can do it any other time. The connection string that you need is what is given here. So very thoughtfully, Amazon's provided us the exact connection string that we need. So I'm copying this. All right, we'll come back to this later. Now open your command prompt and that key file for me is actually, I'm already in Steve. I'll go cd downloads. Doesn't matter which directory you connect from and just paste it, copy paste that. And this is what will come up first. Assuming you got SSH enabled on your system, this is what will come up first. Okay? Don't worry about it. Are you sure you want to continue connecting? Just say yes. This is bound to come up. Even Amazon says in the documentation that is bound to come up. So never mind. Now just connect. Okay. Now you can see that it says there are 4 packages needed for security. I recommend that you actually do the updates. So you can just copy paste it or just write it in manually. So do copy yum update. And it's going to load up all these packages. And if it says, is this okay? Yes. Now it's basically updating your stuff, your environment. All right. So go ahead, please, everyone, and set this up. It won't take very long. You know what you have to do. Copy this, and you must have SSH available on your command prompt. Type it out SSH. If you get a response, then it's there. If it has no idea what SSH is, then you have to do something. Install your client for Windows or Linux or whatever you're on. Then you copy this, and this, if it's not in the same directory where you're running, the connect can be found. Oh, okay. Uh, just come back to your instances, and mine is this one over here. Now you click on connect. See connect. Click on that. And it's a SSH client. You can see from here, so EC2 instances. And this is my particular instance. Okay. So set that up, everyone, and run that sudo update like I've done. I'll be back in a minute.
Sir, can you unmute yourself?
Oh, yes. So connect, go to your SSH client, connect to your instance. Just click connect, go to your SSH client, copy it, open a command prompt. I am in the directory where my file is, my key file. Okay. And then I just copy paste that in like that. And it'll give you some dialogue. Just say yes, yes. And you should be connected. Your prompt will change. You're now on Linux, however you say it. Okay, so now we are not in Windows as such anymore. So we've logged in. So on this particular AMI, there are certain things configured already. Okay, just watch my screen. I'm have to log in again. You simply go to your SSH client, as I've said, copy this command and go to your command window and right click and paste it. Or Control V will work also. All right, and then you will get this prompt over here where I am. Something like that. My username actually is EC2 user. Anyway, you're just copying the full connection string. Okay, now on this particular AMI, there are already certain things configured. There are already certain things configured, like Python, for instance. How about typing this in Python? There you can see 2.7.18 is already installed, and Amazon defines updates as is needed. So let's add a simple text file to this instance. So just type in cat sample.txt. I think a number of y'all must be familiar already with Unix commands. Anyway, this will give us a oops. We haven't created it as yet. What is command vi? All right, so that should give us. So now we can put and to actually save the file and quit is I think a shift and ZZ. No, shift ZZ doesn't work on this. Oh, we have to go back to, then we have to press escape, then shift and ZZ, and we can go back to our command prompt. Then we put in a ls, and here's our sample.txt. Got it. So just follow the same commands. I think you all have experience, a lot of you. Uh, so we have to deal with this VI editor. Unix people love it, of course. So anyway, put vi sample.txt, then press I. I will give you, it will put you in insert mode and type in some message. Good morning EBS or good afternoon EBS, like that. And then once you're done, you press escape. Once you press escape, you'll be put back in command mode. Okay. Once you press escape, you'll be put in command mode. Then you can press shift and ZZ at the same time, and it'll bring you back to the prompt. Then you just do a ls, which is like a dir prompt equivalent of Windows. It'll give you sample.txt. If I do cat sample.txt, it'll show me that, okay, my misspelled hello form EBS. So we've actually, we can do any kind of stuff. Maybe next one we'll install Java or something like that in this. Okay. So we're basically done. We have our instance already set up. We actually logged into it. We put a file on it. We can actually install programs on it as well. Great. So we can actually exit this. Okay. So now what we have realistically is we have an EBS backed instance. This is what we have. We've connected to it. Okay. All right. Let us reboot the instance. And it's successfully rebooted. All right, go ahead and reboot your instance. And then log in again. Because if you reboot, your connection will be closed in any case. Okay, So let us do that. And we have our sample.txt is still there. So that data is persisting during a reboot. That's basically the exercise that we were doing. Simple exercise, but we want to make sure. If you did that with the instance store, okay, in any case, we don't have an instance store to play with, but that's if you with the instance store, it will be there as long as the instance is running. So there's, that's a redundant question. Now, what we should look at now is how do we create a Amazon machine image from this? So before we break for lunch, let us just regarding this, you have an option actually to have PuTTY connect to your Linux instance from Windows using PuTTY, but you need the PuTTY software. But with this, you don't, your SSH should already be enabled on your system. You should already have it. So I find it quite easy, user friendly. It's like I'm working on my own console. Okay, let's see what we'll do. After lunch, we'll create our own Amazon machine image. Now that we have our instance up and running, okay, we'll go ahead and we'll create our own machine learning image. This is actually what we've been looking at in this demo. We've seen all the AMIs that are available. We have AWS managed instances, AMIs. We have the marketplace as we've seen. Oh, and public is there. You also, maybe I should have mentioned, you have your own AMIs. There's a section we'll come and see. Your own AMIs is empty now, like we checked it out before. For me, I created one earlier, so that was there. For you, it'll be there after you create it. We'll do that shortly. Now we launched instances. We did our EBS backed instance, which is currently there. Our instance store backed. We went to the configuration, but it's not available to us because it's a free tier. But in any case, it's an exercise. So you know how to set it up. So that's good enough for now. We don't need it. Even if we had created it, we would have deleted it because we'll be using EBS backed instances. Okay, now regarding creating a AMI from a EBS backed instance. First, we launch an EC2 instance from an existing AMI that is actually close to what we want. Then we customize the instance with any uh, software configurations and data that we want to have ready when we launch a new instance. We then select that instance to create a new AMI and provide a name and description for the new AMI. Now, during the AMI creation process, an EBS snapshot will be taken of the existing instance. This is where EBS snapshots come in. And it'll be registered as the base for the new AMI. Okay. Now, just a note. You will be charged for the disk space of the EBS snapshot that backs your AMI. So when you're ready to launch a new instance, we can select our new AMI, then have all the modifications you be made already in place when the instance starts. When we no longer need the AMI, we'll deregister it. Only then we can delete the EBS snapshot that backed the AMI to stop the storage changes. So there's a link there very closely, and we have to follow a process to get it done properly. So then we delete the EBS snapshot that backed the AMI to stop the storage charges. Anyway, After lunch, we will go through this in a demo so that we can see how it actually works. Okay. So everyone go for lunch, please. Okay. And we'll meet at 2 o'clock.
Sir, Naveen Kumar asked one question, sir.
Yes,
You have
sorry, tell me. You're a
you
little
have to
soft.
you have to change the extension of security pair file.
No, the security file should not be changed. Your security file should have a .pem extension exactly as what is given. There's a link. Once you create your instance and you launch it, right? And then you created your public key pair and you given in a name. I've got EBS demos. Then you have a button, you can click it, it'll download it automatically to your file. Uh, has it come as a text file? Can you tell me? Okay.
Yeah, thank you,
If
sir.
if it's come as a text file, then you should rename it to .pem and see if it works. It should be a .pem file. Private encryption. So Amazon has the public key and you have the private key. Try that. But maybe sometimes when you download stuff from the net, extensions get messed up. But the extension should be PEM. Okay, so everybody go for lunch, please, and I will see you all back at 2 o'clock.
Oh, okay. Thank you, sir. Thank you, Stephen, sir.
Sure.
Dear participants, we will meet by 2 p.m. with the same link. Okay. Thank you. Thank you all.
Thank you.
Dear participants, sharp 2 p.m. we will start the session.
So let us continue.
Yes, sir. Please take over the session, sir.
Yes. Uh, Miss, would you please advise the participants about where they can access the recordings?
Yes,
Oh,
sir. We will forward it, sir. Dear
okay, fine.
participants, we will forward that particular link of recordings. Okay.
Okay, so I'll share my screen. Now we have got our instance running. We are about to, by now everyone must have got the instance up and running. So let us see how we can get a create an AMI from a EBS backed instance. Okay. So what we are going to do, first we'll create the AMI just to give you an overview of what we are actually about to do. Okay, and once we create a new EC2 instance, then we'll see how to deregister it and delete the EBS snapshot that backs it. This is important, especially when you're paying for storage, because when you no longer need a particular AMI. So let us connect. So I have 3, it seems. Okay, I'm only interested in this first one. I'm actually, later on, I'll ask you all to keep a couple of instances running for when we look at some deploying an AWS Lambda to start and stop a server automatically. Now, if there's anyone, who has any difficulty, You can click on connect over here. See where my mouse is? Let me go back. Anyway, as usual, let's connect. Okay. All right. So what we can do over here, let us do something. We'll install Java. First, let's see whether our file is there. Our file is there. That's fine. Let's see you should have created your own file by now. All right. So let us install, we can install Java. Let's see if Java is already installed. I think it's dash dash version. Ah, it is already installed. Otherwise, I'd like you to do this. Do a sudo yum install and then put a Java. Actually, it's going to install. For some reason, it overrides it, but that's okay. This is just testing. Put OpenJDK, not Sun, not Oracle, rather. So just do a sudo yum install now. Java 1.8.0 OpenJDK and let it run. It'll take some time, maybe. Now I'm installing Java because it's something I'd like to have the next time I launch this type of instance. Okay. And after it's installed, you run your Java double hyphen version, and you should see the version like it's showing on my screen. Okay. All right. So go ahead and do that, please. Okay, that should only take not very long. We can go back now. Let's go back to our dashboard, our console home. Let's go to EC2. Come back to our instance. Select your instance. So okay, that was it's always good to spell correctly. So Java is not found. Fine. So what I'm going to do, just so I'm on the same page as you all, we all on the same page, I am going to install Java. So I'll use the yum package. I'll do install JDK, not the JDK. That should be Java 1.8.0 and just put open JDK. Otherwise, I'll be moving ahead of y'all and then y'all will wonder what next. So let's do that. So here is, it'll ask you, is this okay? Just put in a Y, yes. It'll carry on. And that's that. Quick, no? Faster than if you did it on your own machine. Great. Let me do an ls. Our sample.txt is still there. Sample.txt. Okay. Let's go back to our console. Go back to our console. We'll go back to instances. Make sure you're in the right instance. Mine was created at 12:05. Okay. So to create an AMI from this is pretty straightforward. We go to actions. We go to images and templates and we go to create image. Okay. So give it a name and a description. Now we created this from Linux, Amazon Linux 2 with Java. This is a complete image of our instance now. Now notice there's no reboot option over here where my mouse is. Don't click on, don't check it. By default, your instance will be rebooted to ensure that everything is in a good state before the snapshot is created. If you select the no reboot option, you're saying that you know your instance is in a good state, but Amazon won't guarantee the file integrity of your snapshot if you select that option. So when you're all set, then we can simply come down over here and we can go to create image. And it successfully created our image. Okay. So we're in the EC2 section, as you can see, of the AWS console. We can go to images and then we can find our AMIs under images. And here's what is actually this is. Now here's our status. It is pending. Fine. So that is what is so if you followed so far, your image is going to is on its way. Is going to be created. Okay. If you just select it, don't disturb it. you'll see that the status, of course, is pending. Okay, so you can note the AMI name. This is the name that you have given it. I mean, I have given mine. You can name yours whatever you like. And the description, the root device type is of type EBS. Here's our root device name, which you'll see very often. All right, so our image is being created. Now, once the new instance is created, we can actually launch a new instance from this AMI. So we can launch it from here. You see this button over here. Of course, now it's disabled. If I select something, it will say launch. No, I can't launch from here either. Wait. But I would actually, I want us to launch it from over here. In this section, once we go back to instance, there was a section, if you remember, which says my AMIs. I'd like to launch it from there. So basically, that's what we are going to do. We are going to uh, we will launch our image from my AMIs, and then just like how we configured our instance, we'll do the same thing. Basically, most of the defaults are okay. We'll change the security group, and then we should be able to log in to our instance. So while this is carrying on, let us this is one use case for EBS snapshots. Let's look at another use case while we are on this. Okay, we are actually on this use case. Let's take a look at some other use cases. So when we create an AMI from an EBS backed instance, a snapshot is created to back the AMI. Okay, it sounds a lot to take in, because it seems like going around in circles. But let me say it again. You create an AMI. Firstly, you have an instance. Now you create an AMI from it. Okay. Now then a snapshot is actually created, which we will see to back that AMI. Okay, so we have created an AMI from an EBS backed instance. We can also create an AMI from any EBS snapshot to launch a new instance. So some other use cases for EBS snapshots include incremental backup of EBS instances. What it means is that if you create EBS snapshots, like if you create multiple, you will actually, the incremental backup will be stored. The latest one will always store the latest state of your instance, always. Then there's sharing, you can share data between EBS snapshots. Actually, you use a data volume that you snapshot the actual data volume to duplicate and share. And then the other is you can manage snapshot and volume encryption. So that's also pretty powerful. Let's talk a little bit about how EBS snapshots will actually work. Here we are back in Amazon Elastic Block Store, EBS. So the first time you create an EBS snapshot, it'll contain all of the data from that volume. Now, what do I mean by incremental backups? Now, subsequent snapshots will only contain changes that were made since the last snapshot. Okay. Now, EBS snapshots are incremental snapshots, which means that if you delete a previous snapshot, then data in that snapshot which is still referenced will simply move to another snapshot. That's okay, got it. If you delete a previous snapshot, then the data in that snapshot that is still referenced will simply move to another snapshot. So what this means is that it's magnificent how AWS has managed this. But what AWS has done is that it has checks in place to make sure that deleting previous snapshots of a volume does not affect your ability to restore the volume from a later snapshot. That's what it means. So in this example, like when the first snapshots were deleted, the data that had not changed between the two snapshots was simply made available for the remaining snapshot so that a full restore could be made from the remaining snapshot. Okay, fine. So note that AWS uses S3 as the data store for EBS snapshots. Now you can't access that bucket directly. This is like internal to AWS's implementation. But the underlying S3 infrastructure gives EBS snapshots a very high durability. So now that is available, I hope somebody send me on the chat how it's going with y'all. Is your image created by now? Somebody just let me know. Okay. Now, thank you, E2. AWS provides also something called the Data Lifecycle Manager. Now, this actually helps, and we're going to look at it. It helps you to schedule and manage the creation and deletion of EBS snapshots. So you can automatically, I mean, there's a powerful thing for like basically backup and restore we're talking about, aren't we? It's actual image of your existing environment in in all respects. So we can automatically create snapshots every 12 or 24 hours, then configure when to delete snapshots based on the age of a snapshot or a rolling number of snapshots. And then these snapshots utilize tags to identify which instances and volumes to include in a snapshot. Lifecycle policy. So the data lifecycle manager can be a great resource to manage your EBS snapshots. So there are actually several different scenarios that you may encounter relative to encrypted and unencrypted volumes and snapshots, but we won't get into it in this course. But you can check the documentation for specifics. But in any case, I'd like to give you a summary of the actions that you can perform when it comes to encryption. Okay, now snapshots of encrypted volumes are automatically encrypted. And volumes you create from encrypted snapshots are also automatically encrypted. In other words, if something is encrypted, then the default is for it to stay encrypted. Then next, volumes you create from an unencrypted snapshot can be encrypted on the fly. And when you copy an unencrypted snapshot, you can encrypt it during the copy process. So you have a lot of options, a lot. In other words, you can encrypt unencrypted snapshots when making a new volume or when you're copying that snapshot. And finally, you can re-encrypt an encrypted snapshot with a different key. And one thing to note, the first snapshot you take after changing or adding encryption will always be a full snapshot. This is because all of the data has changed due to being encrypted or re-encrypted with a different key, basically. Okay, so let us return back to our demo. Now we have, this is our, here's our machine image. Okay, I hope everyone's got theirs going. You can see successfully created AMI, Amazon machine image, from instance OEDA, which is this one. Okay, fine. So let's move on. Now here's our instance. We will actually go to my AMIs. Okay. So let's do that. And go to my AMIs on the left. See where my mouse is. And here's my two images over here. So I want you to, I'd like you to take you to this screen rather than the other. All right. So now I'm over here. We just simply go ahead and select. So go ahead and select your instance. The one below is what I had created some time back or yesterday or day before, like that. So select your image. Just select it. And we'll come to our instance type. Okay. But not going to do much over here. We're simply going to accept the defaults for the most part. This is instance details is actually basically our networking. So that is also okay. You can add storage. You can see it's more or less the same. Our volume type also is general purpose. I don't want to add any tags. Let's go ahead and see how to configure a security group. But add the rule. And this will be HTTP you must add. Actually, it's not even that necessary, but I just keep it in so that it's accessible from anywhere. But what is really important for our purposes so that we can connect. You see, if you take the existing security group, then it'll give you whatever's there, the default. Now, within that default, you don't have your port 22 available. Try it for yourself and see. So when you try to connect it, you won't get any incoming. You won't be able to connect to your AWS instance. So you have to be careful of that. That's why I was so particular on this part. Okay. Whatever it is, whatever security group you use, port 22 must be available. Now we can simply review and launch it. And once you select, got your key pair is a .pem in any case. Just select that. We can reuse it. All right, so our instances are now launching. Let's go back to our EC2. Now I got 4 instances. One is initializing. Fine. Now this instance is what we have created from our Amazon machine image. Okay, have that clear in your mind. This is what we created. We created our Amazon machine image, and then from there we launched an instance. This is what we've done. It'll be an exact replica of my original instance. So this, the last one you see here, which is initializing, is an exact replica of this one. OEDA has been replicated in OFC 86. Now, after this is done, so y'all have all got to this point, I hope. After this is done, connect to it. Just like there's a number, actually, there are a number of different ways AWS gives you to connect. So, for instance, you can connect in any way you want. As a matter of fact, I encourage you to explore all of them, any or all of them, and whichever that you feel comfortable with, go ahead. It's all up to you. Right. So our new instance, which has been created from the Amazon machine image before, that is getting set up. And then we'll do some testing on it. And then we'll actually see. We should remove it also. I want to show you some things, what happens to the instance that you have created, uh, the AMI or the EBS snapshot that backs it, what actually happens. I just want you to see for yourselves. Okay. There's something we'll talk about. Our EBS snapshots are actually right here. Okay. So there's a lot of stuff. I like to talk to you about sharing data. Actually, what we can do about sharing data with snapshots. Some use cases. regarding EBS snapshots. So if we come back to our slides, over here we have two instances realistically, right? Suppose we actually create an EBS snapshot like of a root volume. Then we create a new image from that snapshot and we launch a new instance. Now that process is actually very similar to how we created an AMI, except now we can choose from an arbitrary EBS backup as a base for the AMI instead of a running instance. Okay. Okay. Let us see how our progress is on our instances. Okay, so very good. So here's our new instance is ready. Let us go connect to our new instance. So it does take time, but still it's worth it. So I'll come back over here and I'll just connect, copy this, and this will come. You just put in yes. Oh, you see, it's given me as root over here. So don't get worried if this happens with you. Ah, thank you, Miss Anjali. So it's normally it comes over here as EC2. That's fine. Okay, so we just change it. So if it happens with you, don't worry. It's a minor thing. EC2 dash user. And here we have our console. So let's see if our Java version is here. And there we are. That direction to install 1.8 doesn't work. It installed actually 11, which is that's also fine. But this means that it has actually copied it faithfully, replicated it faithfully from our instance. Because remember, this is an instance. This is very much an instance. Let's go back here. We'll see that it's a running EC2 instance. So this instance has been created from our machine image. our machine image faithfully replicated the previous instance, which in my case was actually that one, the third one, which was created at 12:05. All right. And then let us see what's in our directory. We do have a sample.txt file still there. So do the same thing I'm doing. Check, verify that your software has been installed on your machine. If you run the Java command, and then that sample text that is should also be over there. So creating an AMI from an existing image can help you do some setup once. This is a great thing. And then have that all ready to go whenever you need it again. Especially if you're launching multiple instances which need the same configuration. Now, when you have an AMI registered, it's backed by an EBS snapshot. So let's go to Elastic Block Store. And underneath that, you'll have snapshots. You'll see a snapshot created. This is actually created by me. Data to share with the team. And whatever's created by Create Image, that that is actually created by Amazon, your console. Okay. Okay. So let us see. Here's our snapshot. The volume is here. Okay. Now, when you're done with an AMI, it's important to actually clean this up. Now, you can't directly delete this snapshot. You can see over here, created by Create Image for AMI, etc. Over here. Created by Create Image for AMI like this. All right. So you cannot actually directly delete it, the snapshot, because it's backing an AMI. The snapshot is backing the Amazon machine image. Got it? So you created your machine image, but that is backed by a snapshot. So you cannot now directly delete it. You have to first deregister your AMI so that no one can attempt to launch something from that AMI. Let's go. Here's our AMIs. And as a matter of fact, we need the ID. So I'll just we don't want to delete if you're actually doing it in a production environment. I want to delete this one. That's the latest one. So firstly, what I need to do is I want to actually deregister it. So just a second. I can simply do it in Paint. I need the ID actually for the AMI. so I can match it with the snapshot. All right, so let me just go back to my snapshots once. My EMI is 01908F, so it's the first one. So this is a snapshot that I wish to delete. Very good. All right. Now let me go back to my AMIs. So what we are doing now, we are cleaning up. We've got our instance running, and I want to show you something very particularly on that. Okay. So as we were discussing, we cannot simply delete our snapshots. That's a no-no. Just because it is backing this. My snapshot is backing my Amazon Linux 2 with Java. So that I cannot delete it straight away. So first select this. I have to actually deregister my AMI. So anyway, so that no one can actually launch anything from, can launch it. So just select actions and then click deregister. And it's going to ask you, are you sure you want to deregister these images? And fine, click on continue and it's gone. Now, once it's deregistered, then we can go back and we can click on our snapshots. And the first one is this, which was created. Let me select it. Okay. And then I can go ahead and delete the snapshot. And why is this important? We won't be charged anymore for that snapshot storage. That's why it's important. Let us go back to our instances. So come back up here. And this last one, this is the instance that I had created. You can see it's still running. Still. This is what I wanted to bring to your attention. And it's going to carry on until we actually terminate it. It's going to carry on. Right? I guess you didn't expect to see that maybe. But this is how it works. And it's actually perfectly valid. So here's the instance that I created from my machine image. And that was backed by that EBS snapshot. Because when I created a machine image, a snapshot is created to back that image. So I wanted to delete the snapshot, but I can't do it directly. So I deregistered my machine image. Then I could go back and to my snapshots and I could delete my snapshots. Okay, so far so good. Now, why is this? You're probably wondering. Maybe you are surprised. So once you've launched your instance, it doesn't matter what you do to that AMI or the EBS snapshot that backs it. It doesn't matter. Whether it stays or is gone doesn't matter. The instance that we just launched, it has its own EBS volume. Now, if we go down talking about volumes, which we haven't paid much attention to because we've been concerned with the rest of this over here. If we go down, and we go to Elastic Block Store and click on volumes. And over here are our volumes. Those instances that are currently running, here's our attachment information. Yes, you see what I had. This was the instance created from the machine image. So this volume is still attached to that. Nothing happens to that because so the instances now, once even you created from your machine image, is still going to have its own ABS volumes, and you can verify that when you go to your Elastic Block Store and then go to your volumes. Okay, so that's how it works with machine images. Now here in our instance, we have Java installed, and we've got us that sample text. Okay. So what like to let's do a demo. Like how we did with Amazon machine images, let's do that with snapshots. Fine. The process will be, of course, very similar, and that's a good thing. It shouldn't be like totally the processes should be like sort of symmetrical. Then you can understand it easily, right? So it'll be similar to how we created an AMI. Now, what we are going to do over here, we will choose an arbitrary EBS backup as the base for our AMI instead of a running instance. Then we'll take a look at our data lifecycle manager, how to use that tool to manage uh, our EBS snapshots. So this is our instance that we had created. Let me go back to our instances again. I want to actually go back to the first instance, not the one that I created with the machine image. So as this one, I don't want to go to the machine image instance. I want to go back to this. I'm keeping it like a sort of, base. So that was this one, OEDA. Fine. All right. So from here, let us go back to we'll go back to our snapshots over here. And then I'm simply okay, better to just do it. So let us select create snapshot. Now over here, you got a choice between volume and instance. Okay, so I'll do instance. Our instance ID is this OEDA. That's stuck in my head by now. So I will click that. Okay. Then I will provide a description for it, provide some description. Say like initial configuration, initial configuration. Now this particular instance only has a root volume. Now, if you wanted to snap additional volumes that were attached to your instance, you could actually exclude the root volume. That's why it's actually over there. So you can see the volume ID is over here is root. Okay, now recall that the initial snapshot will be a full snapshot. So it's going to copy all of the data that's in the volume so that we can restore the full volume from this snapshot. Okay. Once you've initiated the snapshot, if you're actually working on the instances, you can continue working on the instance. That's not a problem. So I think that's all we need. Let me just check once. We've got instance, we got our instance IDs here. That's fine. I don't want any tags. So we can just go ahead and create snapshot. Fine. Go back to our dashboard. Our snapshot is being created, by the way, as you can see. We go back over here to our dashboard, we go to instances, and this is my OEDA. Let's connect to that. Go back to my console. I want to connect to this now. Okay. So now I've logged in over here. And I think I have Java also in here. Yes, I do. Let's create another text file. So I hit I for insert and okay. Okay, now I got two text files. So now we got two different files on this volume. Now suppose I wanted to create another snapshot because the second file was really important. So we'll select our instance again and we'll create another snapshot. Okay, are you all with me? We are going to create another snapshot now, right? Remember what it said from the slides, that snapshots store incremental backup. Now, it actually stores the data that has changed from the previous backup. But if you delete a previous backup, Amazon Web Services very intelligently will relocate the data, the old data, to another snapshot. That's what's happened. So you want to restore a drive, you can restore it from a later snapshot, no big deal. So we go back to our snapshots. All right. So we'll select our instance again. Let's create snapshot. So here's a snapshot that we just made is over here, completed at 2:55. Okay. That was a snapshot that we had created just now from our instance, actually. So a lot of facility back and forth. You can use an AMI to actually create an instance. You can use an instance to create a snapshot, and a snapshot is something that actually backs your Amazon machine image and so on. So you see, there's a lot of moving parts to AWS. So here's our initial configuration, and I need that ID so it doesn't get confusing. It can get very confusing sometimes because there's no tags as such or anything. Okay. All right. So now I'll go and I'll create a snapshot. One more snapshot. I'll select instance. Now this snapshot is an incremental backup. Okay. It actually only needs to contain the data that has changed since the first snapshot. So we have our instance ID, which is OEDA. All right. And then I don't need anything else. I can go ahead and create the snapshot. There we go. So what we are going to do, we can actually, we'll delete the first snapshot. And so we got two different snapshots of the same instance right now. One is initial configuration over here. That was the first one we did in this session. And one that is happening right now. So do you think if we delete the first snapshot, will we still be able to restore a full data set from the second snapshot? Okay. So now what we will do, we'll create an image. Let the second snapshot, uh, we will actually create an image from this snapshot and we'll launch a new instance. Now this is similar to what we did before, but now we're going to create an AMI from an EBS snapshot. Okay, so since it was a root snapshot, it's already populated with the information for me in order to have an AMI. So I'll just give it a name and then I can create it. Now this snapshot, the one that is there, whichever one that y'all have done, and here's my second snapshot, which is just completed right now. Okay, deselect that one. And this first one, I am going to delete. So come to, I can delete it because it's not backing an AMI. So I can delete it. Okay. So here's my second snapshot. And let me go here and it'll come to create image from an EBS snapshot. So as I mentioned before, it's a root snapshot. So it's already populated with all the information that I need in order to have an AMI, right? It's a root snapshot. So everything's there. I can create an AMI now. So I'll just give it a name, something like restore AMI. Okay, so we've got the name over here, this, that. I don't need anything else. I can simply put it on create. And it's a pending image. So if I go to AMIs as usual, here's my restore AMI over here. Right? That's quick. So once this is ready, we can actually, it's ready, fine. We can go ahead and we can actually launch it. Okay, let's launch from here. I've got all that. Add the defaults. Now under snapshot, under storage, excuse me. I got snapshots on my mind now. Under snapshot storage, note the snapshot column. Actually, this is the snapshot that was used to create this AMI. Now this image is going to have a copy of that EBS volume, right? That EBS volume. And once it's running, we'll go ahead and we'll log in. And we'll see, of course, we'll see that it's going to be a logging running instance. So let me just do this. I think that's okay. Here's our instance details, storage, snapshot. We can launch it. And our instances are now launching. So here we are right at the bottom. We have this over here. We have a new instance initializing. Okay. So by now we are at a point where we've created a machine image from an instance. Then we taken an instance and we created a snapshot. We've used a snapshot to create an image, and then we've taken that image and now we created a instance. Okay. This is just to, flex your muscles to get it going where you can see how all these services they interweave in AWS. So don't, nothing to be confused about. Just get with it and it'll be open book for you soon enough. And it's actually the way it's put together is put together very intelligently, for sure, right? Let's take a look now at our data lifecycle manager. This can carry on. We'll come back to it. Now we find this under Elastic Block Store Lifecycle Manager. It's really good, because it can help you manage a lot of your stuff on AWS, your instances and snapshots and volumes, everything. Um, you can just configure it, it'll manage it on its own. So how it works is that this data lifecycle manager, it utilizes tags or on volumes or instances to know which volumes or instances to include in the snapshot lifecycle policy. Okay. So firstly, we need to add some tags. So let me take my original instance over here. Okay. And just come down to tags over here. And it says manage tags, right? So we can add a tag. Just say backup true. You can add another one. No, excuse me. And I'll set this one over here. I'll put it as backup false. And I'll save that. That's all. Now we go back to our lifecycle manager. Excuse me. And I want a snapshot lifecycle policy. All right, a description, we can just put sample PACKUP policy that is there. And then I can put backup. I can enter a value and I'll put fine. I can put true. And this is going to be on instance, not volume. So that's, let's check. We have the target resource types is instance. Our resource tags are initially I put backup true, policy description, policy status is enabled, etc. Okay. Then I can set the policy schedule. Just a second. What happened? Value is required. Oh. So I can just put some schedule over here, give it something, my schedule, and I run the policy uh, every 12 hours, starting at something like 1:30. Okay. Our retention count, I retain 10. I can do count. I can actually also do age. Just to let you know, I can do either of these. It's up to you. So we can, I'll retain 10 snapshots. I can configure different tagging information, enable fast snapshot, restore, or cross region copy, as we can see over here. If you need these, now there's a snapshot of the route that was on the previous thing. You can also exclude the snapshot of the route. You can configure the role as well. Okay. Policy has already been enabled. Fine. And then we can simply go ahead and review the policy. Target resource type, exclude route volume, no. Schedule details. Okay. So when you create a policy, you can either create it as enabled or disabled. So this is helpful if you're getting things set up, but you're not ready for it to start taking snapshots as you want. Then you create your policy. And then you see, after the policy is created, you see it listed under your lifecycle policies. So when the data lifecycle manager has run, you'll see the policies that it automatically creates will be over here in your snapshot list. Over here. Okay. So that's the thing. It's a marvelous help. That's data lifecycle manager. After it runs, you already set your schedule. So according to your policy, it'll run and then it'll create the snapshots and you'll find it set in your snapshot list. And how you'll know, it'll be in the description. Of course, I set for 12 hours. So we're not going to see it today in today's session. But in any case, just so you understand, It'll run, it'll create the snapshots, it'll put it in that list, and you'll find the description created for policy, and then it'll give you, and the name of the policy will be there along with the policy number. Okay. It'll automatically, and that's how you know which one. That's why it's runs on tags. It automatically adds several different tags to the snapshot. Actually, the snapshot description, frankly. The snapshot ID you can't mess with because that's, that's fixed. But to the snapshot description, it adds this. And yeah, so it's pretty neat. So that helps you, these different tags, like your name, like I put sample, what did I put? Sample backup policy. So then it will help with, you know, it helps to identify which lifecycle schedule created it and the instance it came from. It'll give you a timestamp and other information that you may have configured to add to the snapshot as tags. So we are a little bit late with our break. So go ahead, take 15 minutes from now, and I'll see you all back after 15 minutes. All right. So come back in 15 minutes from now. Okay, everybody, shall we continue? So we were on the last bit. Let's finish up this module and move on. Okay. So I think everyone's instance that we had made, just to recap, the instance that we made was from a snapshot of our original instance. Okay, we took one instance, we made a snapshot of that. We created an image from that, and we used that image to create another instance, and we launched that instance. So this is my instance. You can see over here, it's finished, took forever also. It finished at 3.8. I think yours will be done also. Now let's connect to that instance. So I'll come over here and copy it, go to my, and I'll go to my AWS CLI and just simply paste it. Over here is giving me root. That's what actually we log in with. It's actually EC2 users been assigned to me. Okay, so we're connected. Let's see what is over here. I've got my sample.txt file, which I never created on this particular instant. Let's see what's in it. Fine. So it's replicated. Whatever was there in my original instance. Here's the steps. I took the original instance, I created a snapshot from it. From that snapshot, I created actually 2 snapshots. Okay. Anyway, so it is over here. So let me see if my Java version is still available. Okay. So it's replicated that faithfully. The snapshot that I used to create that new instance is replicated my original instance faithfully. Okay, that's good enough. So let's wrap up this module. We're done with this. We're done with AMIs and snapshots and not EC2, but EBS for now. We're going to move on to something different. We're going to look at AWS Lambda. But before that, let's wrap up and let's briefly see what we've actually learned in this module. So we actually learned about AMIs and the variety of sources where we can find them, including AWS managed, third parties in the AWS marketplace, public AMIs, as well as how to create our own AMIs from EBS. And our own AMIs, you remember, it's under, once you launch an instance, you'll have on the left navigation pane, you have My AMIs. That will be where all your custom AMIs are kept. So you've created EBS snapshots from EC2 volumes for incremental backup. And we've seen, lastly, how the Amazon Data Lifecycle Manager helps us to manage those snapshots. We can create a schedule. We can set the number of snapshots to be taken. The Lifecycle Manager will automatically populate our list of snapshots when it runs. Then we took a brief look at how to manage encryption options with our snapshots. That is there. It's simply options that we can choose. And how we can use EBS snapshots to create new volumes to launch new instances. So that's it for this module. So next, let us look at building something. It's called serverless applications. Serverless applications in with Lambda. Very, very powerful feature, really. Very popular also. So what this is about, really, is it's how we actually incorporate AWS Lambda and into some serverless architectures. Okay, firstly, we'll define what is actually a serverless application. Then we'll take a look at how AWS Lambda works. Then we look at some serverless architectures and we'll do a hands-on to demonstrate a serverless application using an API gateway. There are many APIs. REST API is very common, of course. So we'll use an API gateway, AWS's API gateway, and we'll use Lambda. Now there are four key capabilities for a service or a platform to be considered serverless. Firstly, no server management. From the very name, you would expect that, right? You don't have to provision or maintain any servers. There's no software runtime to install, maintain, or administer. Then we have flexible scaling. You can scale your application automatically. Capacity adjustments are actually made relative to units of consumption, like CPU or memory, rather than units of individual servers. Thirdly, we got high availability and fault tolerance is actually built in. So we don't need to architect for high availability because it is provided by the service. Finally, no idle capacity. So you don't pay for idle capacity. So there's no pre-provisioning or over-provisioning for compute and storage capacity. There's no charge when your code isn't running. So there are several different AWS services that can be a part of a serverless application. Now, AWS Lambda is the compute layer where your code is executed. So Lambda is based on functions. Java has a Lambda operator function, came out with Java 8. Basically an anonymous function, which actually gives you a very concise way to represent anonymous functions. JavaScript has the arrow function. Other programming languages call it by various names. But for AWS, Lambda is based on functions where each function contains, of course, it contains the code you want to execute, the configuration for how the code is executed, and optionally one or more event sources that can detect events and call our function. So Lambda is always on and ready to like receive calls. So we don't have to worry about scaling because Lambda will automatically scale to run multiple copies of the function in parallel based on demand. And here's a key point is that it is stateless. So it is up to us to manage state information outside of Lambda. Okay, so how does it work? So at its most basic level, some event source will call your Lambda function, which will execute your code. So in your code, you can interact with any services you want, both inside and outside of AWS. Now, creating it. This is some programming is involved over here. So it natively supports Java, Python, C Sharp, Ruby, Node.js, PowerShell, Go, etc. It also provides a runtime API So that means we can use additional programming languages for our functions, even if they're not native to the Lambda runtime. So basically what we have to do is we create a function code package with all the assets we want to have available locally when the code executes. And this, if you see the figure, is stored in S3. Now, when events occur, the code package will be downloaded from the S3 bucket installed in the Lambda runtime environment and is invoked as needed. So the function code package for our Lambda function has a size limit. If you require more than will fit in the function code package, then we have to configure a function to pull in additional code and content using AWS Lambda layers. A layer is basically a zip archive. It contains libraries, a custom runtime, and other dependencies. Now, layers help to keep our deployment packages small, making development easier, and helps us avoid errors that can actually occur when we install package dependencies within our function code to make it run, like maybe libraries or whatever. The pricing is very reasonable also. It's built in 100 millisecond increments. So the rate you pay is based on how much memory you allocate to the function. So more memory equals a higher cost per 100 milliseconds. Then the amount of CPU and network capacity allocated to your Lambda function also changes based on how much memory you allocate. So as we develop functions, it's important to test, and we can test it on the console. So we can test and measure execution times based on different memory settings. In this way, actually, we can optimize the cost to execute code. So, sometimes increasing the memory, which also increases CPU and network capacity, actually reduces the amount of time to execute our function. So even though we pay more per 100 millisecond increment, you end up saving money because it takes fewer 100 millisecond increments to execute your function. So that's your trade-off. Okay, so S3 by now we know that it's like a storage option, a storage service in AWS. So let's take a look at how we might use Lambda with different AWS services. Suppose we got images uploaded to a certain S3 bucket that need to be resized 3 different ways. So we could write a function to perform the resizing. Then we'll configure the S3 bucket to call the Lambda function every time a new object is uploaded to the bucket. You could do a similar function with an SNS topic. So whenever data is published to a certain topic, then a Lambda function is called and can then do something with that data. How about an SQS queue? SQS queue is actually Amazon Simple Queue Service. SQS for short, another acronym for y'all to remember. It's basically it's a fully managed message queuing service. So what it enables us to do is to decouple and scale microservices and distributed systems. So basically in the end, it's a queue service. Now, suppose we have something like messages in a particular queue contains some information that needs to be formatted, then stored in a database like say Amazon RDS. We could write a function to perform the formatting and store the information in a database, then configure Lambda to pull the queue and invoke the function when a message is inserted into the queue. So you see, Lambda functions are dynamic. and they're always on call 24 hours. So when the function has executed, then the function can remove the message from the queue. So a similar model can be used for Kinesis data stream. Basically, a Kinesis data stream is like a KDS for short. It's a massively scalable and durable real-time data streaming service, in short. So that's why you see data on the left, Kinesis data streams, and that's the target to where it's being streamed. So the data available is collected is available in milliseconds. So this to enable real-time analytics use cases like real-time dashboards, real-time anomaly detection, the stock market. You can think of a variety of uses. So anyway, what in this context, Lambda can pull the stream, can get the stream data from Kinesis, and then invoke the function to act on that data. So many uses. Now, Amazon Lex, it can leverage Lambda to perform fulfillment actions. For example, say we have a chatbot. It needs to be in place, needs to place an order after gathering information from a user. So Lex can then call a Lambda function with that information. Then that function can perform the necessary business logic and order placement with the information gathered by Lex. CloudWatch we covered briefly. It actually, that's what it does. It oversees your application. Now this CloudWatch events, they support schedule events. So we could schedule a time-based event which will then invoke a Lambda function. If you're managing any servers, this could actually be a replacement for cron jobs. I think some of you all might have experience with that, but I was never really into that. So, but cron jobs, we know about it. It can be a replacement for it to perform updates, backups, tests, or whatever other actions that need to happen on a regular basis. Now, we look at this when we go back to our console, Amazon API Gateway. This is a highly available, actually that HA means highly available, scalable, a managed service for APIs. So it can perform your authentication, authorization, and all that, metering, caching, managing request responses to and from backend services, including Lambda functions. So it actually manages your Lambda functions as well. Now, API Gateway fits in the serverless criteria that we were discussing at the beginning of this course, as it's highly available by default. And that is a key component, for serverless architecture. So there's no software to install, or configure, or maintain. It automatically scales based on calls received, just like AWS Lambda. And even though it's always available to service your API calls, you do not pay for idle time, just like Lambda. You only pay for the calls it actually handles. Okay. So anyway, as you move beyond, Hello World examples with serverless applications, uh, it's a good idea to use serverless developer tools to help you more easily build and test and deploy and monitor serverless applications. So there's a whole load of open source third-party frameworks and SDKs for all that. And this architecture model is actually called simply SAM for short. This this serverless the serverless architecture model, as you saw in the previous slide, or SAM, that is actually not part of, that is an open source framework for building serverless applications. So how it works is YAML, you all might be familiar with, just like we have JSON. It's just to represent very often objects. But just like JSON, we have a kind of text formatting. YAML is the same, mostly used for configuration, like JSON. And the difference between that is that it's organized in a kind of a hierarchical style. So you can have a parent element, if you want to call it an element with multiple number of children. So that way is slightly different from JSON, but more or less achieves the same purpose. Anyway, so resources and mappings are actually expressed using this YAML. And it provides like a local Lambda environment to test and debug our functions. Now, this AWS serverless application repository, which we're going to look at now in a couple of minutes, this is accessible through our console. It's a managed serverless repository where we can browse other serverless applications. Okay, so we can publish our own applications to the repository. We can also configure resource level access with IAM to keep it private. We can give access to specific AWS accounts or share it publicly. In other words, we got actually, all levels of access. So for now, let us go take a look at our AWS serverless application repository, and we can deploy a serverless app, not built by us, but we can deploy it and we can use it. So come down here, you can see my screen. I'm going to services and I'm looking for serverless application repository, which of course is under the compute along with all other compute services. So we'll come over here and let's see available applications. Okay, and we got choose public applications and then search for an uploader. This is a nice example. And here we are. So in the results, I can see several different serverless applications that have been deployed. These are all serverless applications free for you to use actually. Depends what you're looking for. So anyway, I'll select this one. Now recall that applications deployed in the repository use the serverless application model or SAM. So they're very easy to deploy. Okay, so here's my uploader. Now under application settings, come down to application settings, bottom right. So I'll configure what is needed for this particular serverless application. All right. So we can just call it something like uploader demo. And the destination bucket. This is something that we need to do. Let me right click on this. I have gone to services and I need to have created a bucket actually before. So you can create a bucket. All you have to do, the bucket is just going to, this is going to hold something like that. Remove block all public access. That doesn't make sense at all. Server-side encryption, we don't actually need. This is where we put, we need this actually for to run this particular AWS serverless app. Okay, so you have this. We put a name for the bucket and then we choose the bucket. We remove block all public access, deselect everything, acknowledge this. No need for versioning, no need for encryption. We can create the bucket, I think. Okay, then give it any name that's available. Okay, so now I have my bucket in place. Very simple. Uh, okay, so here's my okay. So now we have set it up. Here's my Lambda console. This is actually your Lambda console. Fine. And all right, so that's done. Just simply click on that. You can see we have our endpoint over here. This is where we can actually hit that deployed serverless application. This is where we can actually do that. All right. But before we do that, let's take a look at that API gateway that we created. So we can see over here that I have one API, the one that was actually created by this serverless application, which is deployed from the repository. It's a REST API. Let's take a look. Okay. Come over here and click on Get. And once you actually drill into the get method, you'll see how the integration request is of type Lambda proxy. So if you go down here, see how it comes, the method request, it goes to the integration request. It comes to here, the Lambda, if you see, you have to turn your head and to actually see it. Right at the end of it, it's processed over here, it returns a response, the method response goes back to the client. And this is our actual Lambda function. This is actually our Lambda function. So this particular function is written in Node.js. So we can see the code in line over here. Quite neat. Okay. So we'll go back to our applications menu now. Let's set up, okay, here's our applications menu. And then all we actually need to do at this point is we, of course, select our application that is there. So we select the application and all we have to do now is hit the endpoint. And this is a Lambda function which is actually running. So this page is not is provided by the application. So the point of this application is to upload a file to the S3 bucket that you have created. So notice how right now it's empty. There's nothing is over there. Okay. Nothing is over there. Okay. So let's say you create a file. There's some stuff I've just I've just taken a screenshot of this session. Actually, I've taken that. I've taken and I dropped it there. And here you can see kl.png. Even if you refresh the bucket, you'll still see the file where you expect it to be. Firstly, so using a serverless framework actually will save you a lot of time. Let me close this down. Okay, so it's uploaded to my bucket. Fine. Let us go. Let us go to S3. Let us see a bucket that we have created. So I didn't upload it here. I used this one. And here it is. You can see August 16th, 17th at 4:10, which is just about now. We have our kl.png file uploaded over here. So if we if you go through all this, over here on this side, you have a number of different things. You have your access points. You got your actually your Lambda access points, batch operations, and all that. Okay. So what's the underlying serverless architecture means that we can hit a page with 1,000 requests, and the API gateway will actually scale to match these. That's what this actually means. And S3 would also scale to store those. So I could leave this service up indefinitely, and I would only be charged when someone actually hits the API or executes this Lambda function. So that was it for Lambda. Very short module. So y'all are doing great. What we actually learned right in this module is the criteria for serverless applications and how Lambda is a compute component for many serverless architectures. So that's why we are covering it on this today's course on a deep dive into compute. So we reviewed several use cases where Lambda can interact with other AWS services and how Lambda functions work. And finally, you saw how to deploy an application from the AWS serverless application repository where we used API gateway to trigger Lambda functions and perform workloads. Okay, so that's that for this module. Now what we'll do is let's do a couple of exercises. One is like creating and configuring a web server in AWS. So we can take a look at that. That'll be interesting. So let us go back. We have, let's go back to our EC2. Now we got a bunch of instances running. And this is why I was a little bit, I asked you all keep it at HTTP. We don't have to go through the rigmarole of creating a new instance from scratch again. Okay. All right. So what do we actually want to do? What we can do is we're going to actually do some, we're going to launch a web server. In other words, of course, before we launch anything, we have to actually install it. So let's go ahead and do that. All right. So briefly, it'll be like this. Like, firstly, we have to launch an EC2 instance, and it has to be in the public subnet. I believe most of this should be okay. All right. So any of the instances I think will work with this. Okay. We already got a public IP basically a public IP we need in place to actually, obviously a public IP, because otherwise how will it be accessible? Then let's see, storage and all is not exactly relevant over here. Now for the security group, we've already configured it with HTTP. Remember all of this. So let's take any of them. Let's take a look at security over here, how it works out. Security. And here we have, this is fine because our application should be accessible over port 8080, and 22 is necessary so that we can actually connect with using the AWS CLI. So this is very necessary to get this to work. Actually configure and deploy uh, a web server on an EC2 instance. All right, so let us connect. Firstly, we need to connect to it. So choose any of your instances, but remember that security part, these ports must be open. So you can go ahead and connect now to any of them. And I will also bring up my command prompt. And it's not accessible because I'm in the wrong place. Now there is one thing, let's see, we have installed the update. So that is important actually. But in any case, just do this sudo, it won't take time, sudo yum update and put the Y flag. Nothing is there. So that's great. Now what we need over here, we are installing Apache web server. Okay. And that's what's actually going to run our web application. Apache Tomcat. So now actually we need to install the PHP software. Now we have an Amazon Linux extras, and this Linux is free for us, actually is free. So let's go ahead and do that. Just type this in, please. You can see my screen. So it's a little long command and then extras. And then you put in an install. Put in the Y flag. And this Maria dash, no, it's Maria DB 10. There, it's a bit of a long command, but basically what it does is that it installs PHP software using this command. So you can see we are using the Amazon Linux extras install command, and we are installing lamp Maria DB. Is that correct? Lamp dash Maria DB 10.2. Yeah, that seems all right. A dash PHP 7.2, and that's it. Okay. And there you go, it's starting to install it's actually installing the PHP software. And after that's there, only then can we realistically install Apache web server. Installing Apache web server is not a problem. You do a sudo again, do a yum y and httpd, like how I have it here. Okay, so just put this in sudo yum -y httpd. This will install our Apache web server. I'm sorry, what's wrong with me? Yeah, I forgot the install command. How is it expected to install anything without an install command? Thank you. Miss Anjali, thank you. So sudo yum install, I think that should be correct. Yeah, sudo yum install -y is a flag and then the software, and that should run. Okay. Now, this is installed over here. We can actually start our web server. So we go sudo, let me see, system ctl, and then a start and httpd. Sudo system ctl start, no, that's an extra T over there. It's always good to have your spelling correct. Sudo system ctl start httpd. Ah, now we have to test. We don't know whether it started or not. Okay, so for this, the public domain name system or DNS name of our EC2 instance, we have to enter that in the address bar of our browser with a prefix of HTTP. So let us, okay, so now this should be our DNS name. Okay, now we go to our browser. And it should be with an HTTP. Actually, no, this, yeah, I understand what you're saying. You don't need an index file. HTTP colon slash slash. It should be, it'll just give us the Apache start page. It should. And here we are. I must have typed in the HTTP. The first time I did it is, I thought it would be HTTPS, but why will it be HTTPS? It shouldn't. I don't know why I put HTTPS. So you have to put it as HTTP. I'm not sure why I put HTTPS. The first time I was deploying an application. But anyway, or maybe it just come up. Anyway, this is the test page, right? So that if your web server is running correctly, then you will see the Apache test page. Now, if we had more time, we would develop a simple application, or even as Ms. Anjali suggested, we could actually create an index.html, load it up. But this, once you see this, as it tells you, it means that now you can add directory, but this will go in this particular directory. Okay. So now we've actually deployed, we've installed our web server on a EC2 instance, and we've deployed it. I mean, I haven't deployed anything, but we can see the Apache web server test page. So it's actually just used to test that has been, installed properly, and the operations are, it's operational. Now, once you're ready to deploy it, then you create your WAR package or whatever. And of course, you have to follow the rules, the correct directory. For instance, this HTML directory where we'll have most of your static files like your index.html or whatever, and so on. So that's how we deploy, we configure a web server on an EC2 instance. Now, we're not actually done with Lambda as yet. A little bit, okay. There's a little bit left that we should work on. It's a small thing. What we can do is we have these Amazon EC2 instances, right? We have quite a bunch of them, instances. If we select any of them, we can start and stop them, right? If it's stopped, we can start and we can reboot and all. How would we actually do that using Lambda? That would be a nice use case. Okay. So let's try that out. It's I have given actually quite a bit all this stuff over here in your which you can download from your GitHub, and I've left it over here. When you have spare time today, log in, and I want you to change your region that you have over here from US West 1 to whatever your region is, and these are your instances. All right, so I want you to replace these with your particular instances. That's all. What we are going to do, this is one Lambda function, for instance, which is going to start our instances. Over here, you have another Lambda function, which is going to stop them. To test it, Amazon has given us a facility to actually, test it out in the console. And then this is your IAM, your Identity Access Management or policy file. So I don't want you all to have a typing exercise. So this is over here. But if you can set this up, and then this will take only a little while. We won't, because we actually have to set up to actually do this. What we need to do, I'll explain. We have to create a custom AWS identity and access management policy and our execution role for our Lambda function. That is necessary. Then we actually create the Lambda functions to start and stop our EC2 instances. That is these two. Then we test it and we're done. So we can spend about 10 minutes or 15 minutes on that tomorrow. If we'll see what let's do something here. We'll do some partial setup at least. It doesn't take much time. So let us go to services there. I'm looking for AWS Lambda, the console. Okay, and I want to actually create a function. So I'm going to say start EC2 instances. Wow, EC2 instances. Now for the runtime is not Node.js. We will use Python. So just go and do a search over here. You'll find Python 3.9. That is fine. Okay. Now for permissions, click on change. And what we will actually need to do is come here and we need to go to access management. Yeah. Here's a IAM. Okay. And then we will simply create a policy. Now the policy we actually let us do later. We'll do our role first. So we'll click create role. Now this Lambda is already, it's so used so often. Lambda needs permissions to access resources. Everything cannot access your resource. Then we click on permissions. Just say create policy. Okay, this will give you your visual editor. Go to JSON and come down here to the files that I've uploaded and just take that. Come inside here and this is it. It'll tell you what logs are being created, that the effect is to allow, not to disallow. The action is EC2 start and EC2 stop all in any instance. Okay. We don't need any tags as such. We can review it and the name for this policy. No, let's call it EC2 LAMBDA policy 2. Actually, I might have created some policies on the same lines before. So that's about it. And it should be LAMBDA policy 2. And this is start EC2 instances. Okay. So I wanted to do this kind of exercise with you all because give you all some exposure to the identity and access management aspect in AWS. So it'll go ahead and it'll create our policy. So here's our policy, and this is it. So that was pretty straightforward, right? To create that. Now, we also need to actually create a role. And then we simply go and say create role. So policies, as we talked on the very first day, they always link together with roles. Okay, select type of trusted entity is an AWS service. I'm going to take Lambda and permissions. Now, if possible, we want mine is EC2. Oops. Okay, EC2 Lambda policy 2. Okay, now we've associated the role with that policy. We can review it. And that's it. Firstly, we create a policy. Then we simply associate the role with it, with that policy. And that's about done. So now in our management console, okay, wait, this thing. We need to return back to our management console. And we go to, where's our Lambda? Yeah. We're going to choose author from scratch. But we've done that. We have to, now we have to actually create the Lambda functions. We got a policy editor in place. Let's go and create a function. I have actually already created the start EC2. I've created the stop. Anyway, this will be Python. We'll just say use an existing role. And let's see, we have IAM role Lambda 2. Now we can choose create function. This is where some programming comes into the picture. So I come back over here. Let's see, this is Lambda 2. And this is going to start my instances. Here's the runtime settings. All right, so once that is in place, we can simply deploy it. That's that. We're not ready to test it as yet. We'll do that tomorrow. What we're going to do is we should, from over here, from this particular screen, I have to change my instances and choose a particular instance. I have to find my region and replace that over here. In the same way, I have also another function which is going to stop it. And then from this, from right here on this console, we can start and stop our instances. And so it is, and that would be it. But this is where the actual programming part comes in. Now, these Lambda functions, they are always in place. They're over there 24-hour, 24/7. Of course, you only pay for your usage. So you can see they integrate very well with many AWS services over here. So folks, that's it for today. And I shall see you all tomorrow. And we can test this out tomorrow. While you'll have time, just fill in the region and the instances that you want to close down or create. If you don't have enough instances, create 2 or 3 more. Okay. So thank you very much. And I shall see you all tomorrow.
Participants, it's me, Naveen. In the meanwhile, from KU team side, so if you have any problem or any query or any dot, you can post down in the chat box. Participants, we all are here. So regarding the today's session, if you have any query, any dot, please post down in the chat box. Okay, so if not, then we are binding the session. We are meeting tomorrow. Okay. Have a nice day to all of you.